कि ये डाटा जो है हम तो दे रहे, आप अपने हिसाब से देख लो, कोई भी होगा तो रेस्पॉन्सिबिलिटी इज यूअर्स, वी आर नॉट रेस्पॉन्सिबल फॉर एक्यूरेसी ऑफ द डाटा। सो मतलब डे वन में द डाटा को ही हमने इनवैलिड, मतलब हमने उसका ओनरशिप नहीं लेते हैं। नाउ टाइम हैज कम कि हमको डीपीआर का डाटा को ओनरशिप लेने का सिनेरियो आना चाहिए। तो एनएचआई में इसके बारे में काफ़ी डिस्कशन हुआ और एक पॉइंट ये आके बैठ गया लास्ट में कि दी बिकॉज ऑफ एग्रेसिव बिडिंग, ओके बिडिंग एग्रेसिव होने में कोई दिक्कत नहीं है, जो क्वालिटी आउटपुट आ रहा है बिडर्स का विद रिस्पेक्ट टू दी कोट्स आजकल जो आ रहा है, इसका अंदर में काफ़ी ज़्यादा फर्क आ रहा है, क्योंकि जिस कॉस्ट में एक डीपीआर का काम नहीं किया जा सकता है उतने कोट में आजकल बिडिंग हो रहा है। तो टेकिंग दैट इनटू एस्पेक्ट, तो एनएचआई इज contemplating some sweeping changes in the DPR procurement altogether to see that at least the quality manpower, the talent of the market should be attracted to work with NHI or NH related works जहाँ पे DPR के ऊपर उसका वो करना है। इसके लिए वो ट्राइंग फॉर सर्टेन चेंजेस। आने रहे आगे ना वैसे one of the मतलब important changes what you are contemplating, mode of procurement will be now 100% fixed cost. The cost will be fixed because we have now enough experience to understand what is a reasonable cost required per kilometer cost depending upon the project nature and topography and other issues, ki whereby we can expect a good quality output from a design consultant or DPR consultant, taking into account of all the aspects of DPR that to be taken into. तो पहला चेंज हम ये कोशिश कर रहे हैं, हम will go for quality based selection on a fixed cost model, meaning by that the H1 bidder which has the highest technical score, he will be getting the project. So इसका तो पहला मतलब this is the first change we are contemplating. नंबर 2, जो डीपीआर को हमको करना है उसको हम किसी भी मतलब अभी प्रेजेंटली क्या हो रहा है, डीपीआर तो हम रूटीन बेसिस में कर लेते हैं, बट देयर इज अ लार्ज गैप बिटवीन द डीपीआर प्रिपरेशन एंड एक्चुअल इम्प्लीमेंटेशन ऑफ द प्रोजेक्ट. सो इट इज अ सेल्फ व्हाट यू कॉल मतलब एनएचआई का अपना एक हम प्रतिबंध लगाना चाहते हैं, जो प्रोजेक्ट हमको लगता है कि ये फ्यूचर में नियर फ्यूचर में टेक ऑफ होगा, किसी स्कीम में है या किसी प्रोजेक्ट इम्प्लीमेंटेशन स्टेज में है, तभी डीपीआर को हम फाइनलाइज करेंगे, उससे पहले हम सिर्फ फिजिबिलिटी करके छोड़ देंगे. सो हम क्या करेंगे, फर्स्ट डीपीआर विल स्प्लिट इनटू 2 पार्ट्स, वन इज फिजिबिलिटी स्टडी एंड अदर इज डीपीआर कंसल्टेंसी. फिजिबिलिटी के बाद बॉलपेक डिटेल्स लेने के बाद वी विल अंडरस्टैंड द प्रोजेक्ट इज वेदर वायबल और नॉट, वेदर द प्रोजेक्ट विल बी इंक्लूडेड इन एनी ऑफ द current schemes of the government, then only you will go for DPR, so that the gap between the DPR preparation and implementation or procurement of the project is minimized. उसके बाद हमने क्या देखा है, डीपीआर के अंदर में जो मैन मंथ्स इनपुट जो लेते हैं वो एक्चुअल बेसिस में नहीं होता है, क्योंकि डीपीआर इट इज सबको पता है कि डीपीआर का जो डाटा है फील्ड में डाटा कलेक्शन होता है, बट डाटा कोलेक्ट होता है हेडक्वार्टर में, डीपीआर कंसल्टेंसी का हेडक्वार्टर में बैठ के, बिकॉज द पर्सन हैज टू हैव सम काइंड ऑफ इनपुट डाटा एट द हेड ऑफिस, सो दैट ही कैन जो भी डाटा कलेक्शन होता है उसके ऊपर में काम करके कोलेक्टेड डाटा के ऊपर डीपीआर का प्रिपरेशन होता है. इसलिए हमने स्प्लिट कर रहे हैं कि साइट का इनपुट कितना रहेगा और हेड ऑफिस का इनपुट क्या रहेगा. इट इज ए पार्ट इनपुट फ्रॉम बोथ सेक्शंस दैट विल बी गिवन अपफ्रंट. दूसरा एक है, कई जगह पे हम ये करते हैं कि डीपीआर का टाइम पे बिकॉज ऑफ द गैप बिटवीन द डीपीआर प्रिपरेशन एंड द इम्प्लीमेंटेशन कई बार चेंजेस हमको करना पड़ता है. पहले हम 2 लेन पेव्ड रोड बोलते हैं, बाद में 4 लेन कहते हैं, बाद में अलाइनमेंट चेंज कर देते हैं, देन वी गो फॉर ग्रीनफील्ड अलाइनमेंट, सेट लॉट ऑफ चेंजेस वी डू विद द डीपीआर कंसल्टेंट आफ्टर ड्राफ्ट डीपीआर इज सबमिटेड. तो उसमें क्या होता है, क्वालिटी सफर इसलिए करता है कि डीपीआर कंसल्टेंट को ही डजंट गेट कंपनसेशन फॉर द एडिशनल वर्क डन बाय हिम. तो हम एक प्रोविजन रख रहे हैं, इन केस वी आर गिविंग एडिशनल जॉब additional work, we will compensate that money with the DPR consultant so that adequately वो compensate हो जाए, जो काम करना है proper due diligence के साथ हमको document दे दें. टाइम बेस्ड मैनर में हम डिलीवरेबल्स को कर रहे हैं. पहले डिलीवरेबल्स काफ़ी कम था, 5 से 7 डिलीवरेबल के बेसिस में परसेंटेज पेमेंट कर रहे हैं. अभी हम इस डिलीवरेबल्स को काफ़ी ज़्यादा कर रहे हैं, अराउंड 20 से ऊपर डिलीवरेबल्स करेंगे, सो दैट ईच डिलीवरेबल विल हैव ए मॉनिटरिंग मैकेनिज्म एंड उस डिलीवरेबल के हिसाब से उसका हम रिजेक्शन या एक्सेप्टेंस करेंगे और उस डिलीवरेबल के ऊपर में उसको पेमेंट भी करेंगे. इसमें 2 फायदा होगा. एक तो होगा कि मतलब एक टाइमलाइन के बाद जब डिलीवरेबल पूरा हो जाता है उसके बाद कोई चेंजेस करने में एक तो टाइम लगता है. दूसरा, कैश फ्लो ऑफ द डीपीआर कंसल्टेंट सफर्स बिकॉज यू गेट द मनी आफ्टर फेली लॉन्ग ड्यूरेशन. तो हम डिलीवरेबल्स को बढ़ा रहे हैं, अराउंड 20 डिलीवरेबल कर देंगे और उसका परसेंटेज अमाउंट भी फिक्स्ड है. सो इसमें दोनों साइड का विन विन सिनेरियो आएगा. जो एलए लैंड एक्विजिशन करते हैं वो इज ए वाइटल इंफॉर्मेशन गिवन बाय द डीपीआर कंसल्टेंट. कई बार क्या होता है कि डीपीआर कंसल्टेंट का एलए का ऊपर में दे आर डिपेंडेंट ऑन सर्टेन कंसल्टेंट हु आर डूइंग जॉब ऑन द ग्राउंड. तो एनएचआई इज नाउ थिंकिंग ऑफ empowering the LA consultants so that they will have some ownership, they will be encouraged because they will be identified and linked with the NHI. But वो LA empanelment NHI एक routinely मतलब एक empanelment process में जो भी rolling portal type का करेंगे 12 महीना होता रहेगा. और consultant को DPR consultant को they have to take the help of the empaneled LA consultant for the purpose of LA land acquisition. But however, if a DPR consultant have their own team, own LA team, they can also themselves get empaneled and they can do the job themselves also. Similarly, जो इन्वेस्टिगेशन डाटा, इन्वेस्टिगेशन और जो लेबोरेटरी डिलीवर्ड डाटा आता है, जो सबसे ज़्यादा गैप उसमें आता है, जो भी सॉइल इन्वेस्टिगेशन या जो डाटा सम वट एवर वी गेट द आउटपुट, दोज आउटपुट्स आर invariably different from the what you are getting when confirmatory boring is done by the concessionaire or the contractor when it reaches the site. The gap is because the investigation of soil investigation is done by not qualified persons और जिसके ऊपर हमारा कोई कंट्रोल नहीं रहता है. और DPR consultant to save some money they engages the investigation agencies who are not capable of doing this data. एक तो सैंपल कलेक्शन से लेके सैंपल इंटरप्रिटेशन से लेके उसका जो भी आउटपुट आएगा उसका तीनों का ऊपर कुछ ना कुछ मतलब वेरिएंस आ जाता है. तो इसके लिए भी हम कोशिश ये कर रहे हैं उनका भी एम्पैनलमेंट कर दिया जाए विद सर्टेन बेंचमार्क फिगर्स एंड सर्टेन रिक्वायरमेंट फ्रॉम देयर पास्ट एक्सपीरियंस. क्वालिटी बेस्ड इन्वेस्टिगेशन एजेंसी को भी एम्पैनल कर देंगे एंड दैट दे हैव टू बी कंपल्सरली यूज्ड बाय द डीपीआर कंसल्टेंट सो दैट बिकॉज वी आर नाउ ट्राइंग टू go to a scenario when DPR डाटा को हम ओनरशिप के साथ ओन करके रीजनेबल एक्यूरेसी डाले ताकि डबलिंग ऑफ द डाटा कलेक्शन और जो बिल्डर्स को जो सहूलियत मिलना चाहिए वो उसका यूसेज करने का सिचुएशन में आ जाए. इनोवेशन टेक्नोलॉजी ड्रिवन टूल्स का ऊपर में इनोवेशन और इनोवेटिव मटेरियल्स इनोवेशन का ऊपर और जो लेटेस्ट टेक्नोलॉजी और टूल्स के यूज करने का ऊपर जो उसको भी तवज्जो दे रहे हैं. जिसका एक्सपोजर है एक्सपीरियंस है उस डीपीआर कंसल्टेंट्स को वी आर गोइंग टू गिव सम एडिशनल वेटेज. सिमिलरली मॉडिफिकेशन मार्किंग शेड्यूल में कम कर रहे हैं और टेस्टिंग के लिए जिसका ओन इक्विपमेंट बेस्ड मतलब अपने पास है डीपीआर कंसल्टेंट के पास जिनके पास लेबोरेटरी है उस सब के ऊपर भी हम तवज्जो दे रहे हैं. उनको भी एडिशनल मार्किंग देंगे क्योंकि अल्टीमेटली द बेस्ट कंसल्टेंट विल गेट द जॉब. तो उस बेसिस में एवरीथिंग इज पॉसिबल टू सी दैट he has the best resources at his disposal and also resources means including the human resources. तो human resources का भी हमने जो requirement है उसको भी upgrade कर रहे हैं. We are also trying to encourage the talent pool who will be now coming into this. तो इसके लिए एक ही point है क्योंकि DPR consultant का जो आज का जो quotations है that cannot मतलब that is very difficult with that kind of quote to attract the good talent from the market. तो जो अच्छे लोग हैं दे आर नॉर्मली वर्किंग फॉर द एमएनसीज दे डू नॉट वर्क फॉर आवर प्रोजेक्ट्स. तो उसको ही करने के लिए वी आर आल्सो ट्राइंग टू गिव सर्टेन काइंड ऑफ एडिशनल मार्क्स फॉर इंटरनेशनल एक्सपोजर for having people who has the exposure in international magazine में लिखा है या कोई कोडल में प्रिपरेशन में हेल्प किया है या ARC में कोई काम किया है, जो पीपल हैविंग ए वेरियस नॉलेजेस एंड उनका हम थोड़ा सा वेटेज देने का कोशिश इसमें कर रहे हैं. सिमिलरली सर हम अपनी एक 100 किलोमीटर के लिए हमने जो कोशिश किए है, वी आर नाउ गेटिंग अराउंड, जैसे चेयरमैन साहब बताए थे, 100 किलोमीटर का बालपेक फिगर अराउंड 5.96 विथ GST और है 6 लाख के आसपास आ रहा है. बट दैट विल बी 100 किलोमीटर विथ स्पेसिफिक काइंड ऑफ रोड्स, जो मतलब डिपेंडिंग अपॉन द टोपोग्राफी अदर थिंग्स आउटसेट में उसको डिसाइड करके बोल दिया जाएगा फॉर द कंसल्टेंट के लिए. जैसे मैं बताया था आपको फिजिबिलिटी स्टडी में क्या क्या कंपोनेंट्स होएगा, जिस बेसिस में हम डिसाइड करेंगे कि प्रोजेक्ट को वेदर वे टू टेक फॉरवर्ड द प्रोजेक्ट एंड गो फॉर द वायबिलिटी और नॉट. ये पहले 3 महीना में ट्रैफिक स्टडी, अलाइनमेंट ऑप्शन, ब्रॉड स्ट्रक्चरिंग फीचर्स, यूटिलिटी शिफ्टिंग, कॉस्ट, बालपेक फिगर, फाइनेंशियल फिजिबिलिटी करके देन विल डिसाइड द प्रोजेक्ट को करना कि नहीं करना. DPR के अंदर में जो हम कंपोनेंट्स हमको बात करना चाहता है, तो इसके अंदर में वी आर नाउ गोइंग फॉर टेक्नोलॉजी. आई मेंशन NSP का टेक्नोलॉजी होगा, जियोटेक्निकल इन्वेस्टिगेशन इन ऑल फील्ड्स, स्ट्रक्चरल डिजाइन, ऑल दिस आर नॉट न्यू थिंग्स बट वी आर जस्ट ट्राइंग टू गिव दैट कि ये सारे इंफॉर्मेशन सेकंड फेज में होगा, सो दैट द प्रोजेक्ट का जो डिटेलिंग आएगा दैट विल बी अलाइनिंग विद द प्रोजेक्ट टेकिंग ऑफ. मेनवांस का भी जैसे मैं बताया था, डिजाइन ऑफिस और साइट ऑफिस का भी हम अलग अलग करके बता देंगे. जो मैं बता रहा था कि 20 एक हम बाइफर्केशंस कर रहे हैं कि जो स्टेज वाइज पेमेंट करेंगे, ये इसलिए करने की कोशिश ये कर रहे हैं ताकि हम ईच स्टेज में बेटर ओवरसाइट रहेगा. दूसरा कंसल्टेंट के लिए भी पेमेंट का एक कैश फ्लो ठीक रहेगा. हम बोनस प्रोविजन भी रख रहे हैं, जल्दी काम करेगा. मतलब इफ यू डज ए लैंड एक्विजिशन अर्ली या कुछ काम LA का भी काम, कंडीशन प्रेसिडेंट्स उन्होंने जैसे बताया कि वो मेरा प्रोजेक्ट प्रिपरेशन का टाइम इम्प्लीमेंटेशन स्टेज में जल्दी हो जाएगा. देन वी विल आउट जहाँ पे COS अगर नहीं आएगा, दैट मीन ए वेल प्रिपेयर्ड DPR विल गेट around 5% additional bonus. That is also we are giving in upfront project preparation में. कंट्रैक्ट के अंदर इसी हिसाब से जो रिलेटेड चेंजेस है हम कंट्रैक्ट में करेंगे. एक तो रिपीटेशन का चार्जेस देंगे जैसे बताया था, और डिलीवरेबल के साथ ये टू गिव मी कि 40% पेमेंट जो है वो बताना पड़ेगा किस स्टाफ को कहाँ यूज किया है. इट्स नॉट दैट एक सिंगल आदमी जाके काम कर ले और इधर उधर से इंफॉर्मेशन निकाल के दे दे. वी आर व्हाइल यू आर पेइंग हैंडसमली, at the same time we will have a oversight on the deployment of the staff and also the deliverables. उस दोनों का ऊपर भी हमारा कंट्रोल रहेगा. तो इस बेसिस में जो भी मॉडिफिकेशंस, आई एम नॉट गोइंग टू मॉडिफिकेशंस ऑफ इट बिकॉज इट लॉन्ग मॉडिफिकेशंस, बट ये चीज में करने के बाद व्हाट आर थिंकिंग कि इट विल नाउ attract the talent and the bigger consultants who are not coming for the DPR. मैं एक चीज बताना चाहता हूं कि आज का डेट में AEI सिलेक्शन में DPR कंसल्टेंसी का या 2-3 मिनिमम रिक्वायरमेंट है. तो बड़े कंसल्टेंट क्या करते हैं, या 2-3 का बिड करके उसको लिंगरिंग करते हुए दिखाते हैं कि मेरे पास 3 DPR है, सो आई एम एलिजिबल फॉर AEI. बट वो होल हार्टेडली DPR नहीं करते हैं. इसमें हम ये चाहते हैं कि होल हार्टेडली टैलेंटेड मतलब लोगों भी आए और DPR कंसल्टेंट भी आए, ठीक ठाक उनको मतलब सैलरी भी मिले और हमको आउटपुट अच्छा मिले. दिस इज द बेसिस बेस्ड ऑन व्हिच वी आर ट्राइंग टू डू दिस. वंस इट इज अप्रूव्ड वी विल गो फॉर सम पायलट प्रोजेक्ट्स को हम बहुत जल्दी इसके साथ बिडिंग करना चाह रहे हैं. थैंक यू सो मच. थैंक यू.
Thanks, Mr. Padi, for giving very detailed information on the modification of TOR and future way forward for DPR preparation. Now I request Professor Ankit Gupta, IIT Banaras.
Good afternoon, everyone. Members on the dais, the topic which I'll be discussing, because we have distributed the topics which were the part of this panel, is a cost optimization. And believe me, I don't feel that I'm so qualified to talk about this topic in much more detail. So I'll be just pondering upon some points. The discussion probably it's a two-way kind of a thing, so I'll not be discussing much on the points. There are few phases I would like to basically mention. The topic is cost optimization. It's not a cost reduction. Okay, although we are only emphasizing the reduction part, not the optimization part, but this is something very important. And when I say cost, everything is a cost. It's not only my pocket money that is the cost. Okay, so this is most of the part of the presentation I have tried to taken up from a report which probably KPMG has done with a consultation with the NHI experts for making a cost optimization or a cost optimization report for the NH projects, or basically for the ministry projects. There is so difficult thing which can be discussed within a tenure of 5 to 7 minutes, but a cost is a very typical term. Okay, so money in the pocket is one form of a cost, long-term cost, short-term cost, road user cost. There are so many things in the cost which we need to understand. But probably most of the times our focus is only on the in-pocket cost. Okay, so even the GFR by which the government system basically runs, it also talks about the whole life cycle cost. Okay, so again, what is a life cycle cost? It's a very complicated definition, and everyone can mold the life cycle cost in its own way. Similarly, sustainability, it's probably one of the buzzword which we always talk. But there is no one perfect indicator for a sustainability which I can define in my way and you can define in your own way. So there are so many typical terms when you go into the whole life cycle cost, sustainability, that it creates so much of discussion point. Okay. So again, I'll be just talking very briefly these points. Only few points where I have some little knowledge. I'll just try to put down my questions for some kind of a discussion onwards. Okay. So again, you all are basically having some better knowledge than me about selection of the alignment, factors behind selecting the green field or the brown field. This is probably one thing where we need to see. Again, short-term vision can be one thing and a long-term vision can be a different thing. The modifications in the standard of rates, because SOR rates normally being followed by the states. So how these lead distances will vary if it is working in the for the NH projects. Again, that can be a point of a discussion. Many times we see that the drawings are being standardized. Okay, so again, when we do the standardization, there are some positive impacts of the standardization, there are some negative impacts. Because for a small issue, if we make a standard drawing or if we are using the standard drawing, we are basically investing much more amount of money on it. But if we are modifying that drawing for a small issue, then probably we can achieve certain kind of a economy. So again, those standardization as always has two-sided impacts. One is positive, one is negative. The choice of a pavement, this is something like, because my area of expertise lies in something in the pavement engineering. So this is something which I always like, that what is the choice of the pavement and how this is driven. Okay, how the design life is being coming. Okay, like how can I say this project should be designed for 300 MSA or through 200 MSA. So what is that factor that this 200 is coming? I know there is a proper kind of a scientific methodology for coming out of a traffic estimation. But again, there are so many questions from a researcher side, from a person who looks the things in a different way, that how this scientific methodology is really being implemented in a scientific way. Similarly, the estimated traffic, optimal design, the choice of the layers, the choice of the mix, and again, if I'll make the code the word, the VDF, the vehicle damage factor, and the overloading. Okay, so same thing which I have not mentioned in any of my presentation, but this is again a buzzword which we need to see. Similarly, separate design traffic for the LHS and the RHS. Probably every project needs to come on this point, like whether we really need some separate traffic for the LHS and the RHS side. Recycling is again one of the aspect. Probably the next speaker will take in a more detailed way. Drainage design, okay, so how to design the drainage, open drainage or the rectangular drainages. So there are different type of the drainages designs are there. Type and the span of the bridges, although I'm not very expert in the structures part, but probably the type and span of a bridge is again a question which the general people or some engineers always have a mind that how they come to a point that this is the type of the bridge and this is the span of the bridge. Okay, structure of the RE wall, or you need to go with the elevated structure. Provision of ATMS. When I read the word ATMS, the meaning is Advanced Traffic Management Systems. And when I see these kind of the ATMS centers of the NHAI or the other organizations, It is basically more like a camera-based system, and I'm just following the traffic accidents. So is it the whole advanced traffic management system is only being implemented only for this cause, or probably we can get some more benefit out of it? Okay. Similarly, one part, because my previous presenter mentioned about the traffic, the DPR thing. I know I was a part of a G3 committee in the IRC, and there was sometime a discussion that probably sometime this sustainability or the carbon footprint will be a part of a DPR calculation, because there was some discussion about the green bonds and the financing of the road projects from the World Bank on the basis of the green calculations. So again, sometime maybe later, this portion can also be a part of a DPR preparation where we are considering the total amount of the carbon footprints which are expected to basically come in a kind of a project. Although the guideline is almost ready, although the revisions in the guideline may be done subsequently depending upon the problem or the issues which may arise. So the SP 133 talks about this, how to basically find out the total amount of the carbon footprints for a road project in the initial DPR stages. Okay. Again, probably Chairman sir talked about the Schedule B and C. So again, there are so many discussions. You all know what are the issues. Again, the Schedule B and C probably more optimized. I am again using the word optimized. Ranking of the contractor and concessionaire. This is again a very interesting thing. Okay, in the US or in some Western countries, they have their own systems of ranking the projects and similarly ranking the contractors and the concessionaires. We need to develop this kind of a methodology. This is one way of awarding the projects, but probably this kind of a ranking again can be more seriously done. Adoption of innovative materials, there is a lot many discussions. Inclusion of performance test and monitoring. Okay, so again, operation and maintenance part was least neglected as quoted by the chairman sir. Performance test is something like we are designing the mixes, we are laying the mixes. Okay, what is the check that whether these mixes are sustained enough to go for the whatever the distresses like rutting and fatigue or not. So nowadays, because we on the research side, I trying to develop some kind of a more good performance test, but probably now it's a time that we can make this a part of our habit. Okay. Similarly, quality control, quality assurance needs to revisit and redecide. Revisiting the roles and responsibilities of agencies, concessionaires also, contractors also, AEI also, and even the third party like us also. So again, there should be some revisit on the roles of each and every part of us. Innovative survey methods, as discussed in the first presentation, precast constructions. Again, there are so many methodologies for this precast construction. So we need to come up with some carefulness in the adoption of these technologies. Incentives of such kind of a methods, if they are using, probably in the DPR can be given, or probably in the project cost can be given. Detailization is probably the need of the hour. Increasing the maximum limit of the effective subgrade, like till now we are using 100 MPa or the 15 CBR is the maximum thing. Theoretically, it can be decided like on a higher side also. Maybe we can go up to 150 megapascal of the effective modulus of the CBR. But I still have a reservation on that side because the quality control needs to be again revisited and reassured that either till date, whatever even the 100 MPa which we are discussing, we are able to achieve that or not. Okay. Similarly, design of the stabilized basis for the perpetual pavements. Specifically, till now it has been seen that with the use of these high modulus layers, we are trying to reduce the thickness of our top layers, or basically the bituminous layers. But again, these basically these stabilized layers are not designed for a long life, like only for a 20 years with the international experience. So we need to again rework on the stabilized basis like the CTB specifically for a longer life period, maybe 30 years or 50 years. So the endurance limits till now it has been discussed is only for a 20 years, which has been taken from some international experience. So again, in the perpetual pavements, if you are using this kind of a layer, we need to be very careful. Okay. Similarly, curing time for the stabilized bases and the stabilized bases, again, there has been lot many discussion that why to wait for 7 days, can we do it in 3 days or so. Again, it should not be done only on a theoretical basis or only on the discussion basis. We should have some sufficient data to justify that whether the 3 days curing is giving me a good strength initial and the performance at least over a certain period of a time. Okay, even if I'm not getting a performance over a certain period of a time, probably I'll say it is very early to decide on this. Paved shoulder width like 2.5 meter, paved shoulder 1.5 meter, earthen shoulder, how this value, this 2.5 is come? Why not 2.25 and why not 2.75? So again, there should be some thought process on this values also. I'm not an expert of that tunnel, but recently with the whatever the kind of the tunnel works which has been going on, again, there need to be some rework on the tunnel specifications, selections of a very important topic like a project type, why EPC, why BOT, why HAM. As the sir mentioned in the first session, EPC is Sotela Beta, and then HAM is like Bhatija, and then BOT is like Beta. Okay, so something you all have a better knowledge in this area, how to at least modify the specifications or parameters basically. Some kind of a long-term measures is, we always design for a pavement using the two terminologies or the two failure criteria known as the rutting and the fatigue. Interestingly, this is a very different kind of a design. If you are designing for a rutting, probably you are failing down in the fatigue. If you are designing for the fatigue, probably you are failing down in the rutting. Okay, so we need to come to a balance. So can we think in a different way that for my project, rutting is having a more emphasis rather than the fatigue? So can I design my project for a rutting on a majorly basis, and fatigue probably it is a long-term phenomena, it is coming after the 5 years, it has only 1 or 2 layers which is majorly contributing to the fatigue. So only 1 or 2 layers may be designing for a more fatigue life as compared to the upper wearing courses. So again, that is a kind of a idea for a super pave specification. We do not want to directly bring the super pave specifications to the country because it has a lot of infrastructural requirements, similarly the capacity building requirements also. So again, the establishing the design distress priorities can be a thought process to again optimize the designs. There are some examples in the UK and the western side that they are using some thin surface courses, and these are mostly made of some patented materials. So again, we can try to reduce our thicknesses, but these kind of the materials can be used or layers can be used, but again their performance in our aspect, in our environmental conditions, in our traffic conditions needs to be adjusted. Sustainable and lightweight concrete, ABC, that is the accelerated bridge construction technologies. L1 concept of a bid has been discussed a lot. Probably we need to think about a more innovative procurement techniques. Quantification, as I discussed in the initial part of my presentation, sustainability. How I'll define a parameter for a sustainability. If I need to define my project, I'll be biased for my project. Oh, this is a very sustainable project. If you have to define your project, it is sustainable for you also. So there is a very kind of a disbalance among this parameter. So we need to first of all standardize the parameter of a sustainability and then define some index to it. Okay. Similarly for the life cycle cost. Again, detailed failure investigations has been discussed in the morning also, that every success story should be penned down. For me, I want that at least all the failure stories should be penned down without the name of the agencies, without the name of the stretches, but at least these kind of the repositories should be open to us so that we can learn from the failures also, and there should not be any blame game. Detailed and the scientific performance evaluations. Performance evaluation, a road, normally a 2 years old road, we always say, very good road. It has really performed very well. But if you go to the statistics, you have designed the road for a 15 years or for a 20 years. So again, a scientific performance evaluation is something need of the hour. Okay, and again, this should be open source repository. Capacity building has been talked about a lot. We are some of the elite classes who are sitting in this hall. Can we think of a reverse approach where the capacity building of the lowermost person should be done? So it's the bottom to the top approach can be done, like all the persons who are directly working on the field. Their capacity building is rather much more important as compared to our knowledge building. Some incentives on the faster construction. Is it really a good thing or not? I do not have a very great answer over it. Okay, is it a sustainable thing? I do not have an answer. Okay. Climate resilient designs, probably the next session is totally based on this. O&M cost. Okay, so as I told, initial cost is something different. O&M cost is something different, and again, there are so different methods to do the calculations for the O&M cost. Okay, so again, what is O&M cost? Because it is directly related with the road user. Road user cost study, I still remember there is only one study being done by the Kadiali sir. Okay, that is the only road user cost data which we are having till date. Effective pavement management systems, asset management, okay. For me, who is a academician, sometimes get confused that how these projects are being decided, contracted, awarded to a concessionaire, concessionaire give it to some contractors, contractors again give it to some subcontractors, and there are so many set of contractors which has been involved with the one project. So who is the actual responsible agency? Sometimes it is difficult for me to understand. Similarly, road user cost and its understanding. So one is, I can do a study on a road user cost, but what is my understanding on the road user cost? Okay, so if a road, if I'm not maintaining it for the 2 to 3 months, the 2 to 3 months kind of the data which is, or basically the perception the users are having, it is something, we cannot pen down these things in a certain numbers. Okay, and as a R&D organization, as an academician, I always focus on the sustained and the long-term R&D. I do not have a very much ideas about the way forward, probably some kind of a policy interventions. If some of these points are to be considered in the future, can be thought upon, and some good policies can be made. Some incentives awards to the concessionaires, to the contractors who are doing something different and something good. And again, showcasing these success stories, case studies, conventional projects vis-a-vis your innovative cost optimization projects. Okay, so again, these are some of the initial thought process which I have. Again, as a last word, it's a day of a celebration of excellence achieved, but also a day of setting some higher standards or targets of excellence, commitments, and sustainability. So this is all some little knowledge I am sharing with you. Thank you, everyone.
Thank you, Professor. Throwing light on many aspects of cost optimization, right from starting from DPR to project execution and O&M. So thanks a lot. Now I request Professor Dharamveer Singh, IIT Mumbai, to be a brief presentation. Thank you.
Namaskar. I know this is the time for lunch after maybe, but we are like delay a little bit. I will mix Hindi and English in between. Today's presentations is all about, I think Professor Ankit already mentioned a lot of ideas. I will talk about the sustainable practices and how this approach is not really been understood so far. Though we are talking about the sustainable, but this is a quite buzzword that you can think about. अगर आप बात करेंगे सस्टेनेबिलिटी की, उसमें 17 पैरामीटर्स हैं टोटल एक्चुअली. अगर आपको सस्टेनेबिलिटी रियली अचीव करना है, मतलब आई एम टॉकिंग अबाउट द कंप्लीट इकोसिस्टम, लेकिन सब सिस्टम मे नॉट बी एप्लीकेबल फॉर द हाईवेज. There are few things that you can really control on actually. अगर आप देखेंगे हाईवे प्रोजेक्ट्स के रिलेटेड, पर्टिकुलरली पेमेंट रिलेटेड कंस्ट्रक्शन की बात करेंगे आप, तो there is economic. Definitely you have to think about the economic. Whatever technology, whatever approach जो आप अडोप्ट करेंगे, that has to be cost effective. दूसरी तरफ आप जाएंगे environment के लिए, जो भी approach आप use करेंगे, you have to think कि environment में क्या benefit है. और third is the societal benefit. राइडिंग क्वालिटी कैसा है, किस तरीके का फीचर्स है, हाउ ड्राइवर्स आर फीलिंग गुड व्हेन दे आर राइडिंग ऑन द हाईवेज. तो ये अगर 3 पैरामीटर कोई भी टेक्नोलॉजी आप ले लीजिए, किसी भी टेक्नोलॉजी को आप उठा के अगर इन 3 तराजू में आप तोलेंगे कि भी इकोनॉमिक है, नहीं है, इन्वायरमेंटल फ्रेंडली है, नहीं है, सोशल इंपैक्ट है, जो भी आप करेंगे, इफ दिस सेटिस्फाई ऑल दिस पैरामीटर्स, दैट इज कॉल्ड सस्टेनेबल एक्चुअली. But you can define in your own way that we are going to talk about actually. अगर आप definition की बात करेंगे, sustainability है क्या मतलब ultimately? तो just pay the attention on the last sentence that I have written. आप एक ऐसा काम करेंगे जो आने वाली generation उसके लिए deprive ना हो, मतलब आप उसमें कुछ भी convert कर सकते हैं, आप material select कर सकते हैं, आप technology ले सकते हैं, आप road network ले सकते हैं, जो भी आप कर रहे हैं, something which should not, our generation should not deprive of actually. अब आप रोड सेक्टर की बात अब इसमें करेंगे तो विल डिस्कस की व्हाट एग्जैक्टली इज द टेक्नोलॉजी दैट वी आर टॉकिंग अबाउट. देखिए बड़ा सिंपल सा एग्जांपल है. एक कंस्ट्रक्शन मैंने किया है, जो रेड लाइट आप देखेंगे इसमें, एक कंस्ट्रक्शन मैंने किया है. बोथ द पेमेंट्स हैव बीन कंस्ट्रक्टेड सेम टाइम. somehow the construction quality is not up to the mark, assume, और दूसरे में कंस्ट्रक्शन क्वालिटी हैज गॉन स्लाइटली बेटर. अगर आप देखेंगे उसका लाइफ टाइम और उसका ट्रैफिक लेवल जितना वो ले सकते हैं एक्चुअली, देयर इज ए ह्यूज डिफरेंस बिटवीन द टाइम, द एक्सटेंशन टाइम विच इज देयर एक्चुअली. That is called one of the definition you can think about the sustainability, but in terms of the functional, structural, and then longevity actually. Sustainability, if you think about, it comes in everywhere. It is a package. रोड बनाने से पहले भी है, रोड बनाने के ड्यूरेशन में भी है, और रोड बनने के बाद में भी है. ऐसा नहीं कि रोड बन गया और मेरा काम खत्म, अब सस्टेनेबिलिटी की कोई जरूरत है नहीं. You have to practice that during the construction also, and you have to practice after the construction also. This is the life cycle of the kind of system that we are going to talk about. देखिए कुछ एक पेमेंट में एग्जांपल दिखा रहा हूं आपको एक्चुअली. And these payments had been damaged within few months or within a few years. एक साल के अंदर, 2 साल के अंदर. अगर आप थिकनेस की बात करेंगे मुझसे, तो थिकनेस ऑफ बिटवीन पेमेंट इज 300 mm, थिकनेस ऑफ कंक्रीट इज 320 mm. सस्टेनेबल है. एक साल में पूरा बेकार हो गया, वापस से रिकंस्ट्रक्ट करिए, वापस से मटेरियल लेके आइए, वापस से थ्रो करिए. अब you see the cycle. And this is not only one project, there are multiple issues that we are facing actually. Sometimes we implement the technology, then we regret why we have done that. And in fact, in the morning, you have seen the examples also. So that's what we are thinking about actually. क्या करना क्या है ultimately? और किस तरीके का clauses लेके आने हैं और किस तरीके का ecosystem develop करना है, मतलब that is important. देखिए, this is how we defeat the sustainability actually. आप सस्टेनेबिलिटी की बात कर रहे हैं, मैं डिफीट की बात कर रहा हूं एक्चुअली. आप बोल रहे हैं कि मुझे अचीव करना सस्टेनेबिलिटी, मैं बात कर रहा हूं कि आप कैसे डिफीट कर रहे हैं उसको. एक मेरा रोड बनाया, प्रीमेच्योर फेल हो गया, डिफीटेड. आपने डिजाइन किया, बहुत ही थिक पेमेंट डिजाइन कर दिया, अगेन इट हैज बीन डिफीटेड एक्चुअली. आपने अनरियलिस्टिक डेटा अज्यूम किया ट्रैफिक का, और बाद में आप बोल रहे हैं कि ट्रैफिक की वजह से ही पेमेंट फेल हुआ. अनरियलिस्टिक डेटा, दैट इज अगेन यू हैव डिफीटेड एक्चुअली. और रिमेंबर रखिए 3 पैरामीटर जो मैंने बताया आपको, इकोनॉमिक, सोशल, इन्वायरमेंट. अगर आप इन सभी कैटेगरी को 3 पैरामीटर में लेके जाएंगे, यू कैन ऑलवेज टिक मार्क. प्रीमेच्योर फेलियर सपोज फॉर एग्जांपल सोशल है, नहीं. एनवायरमेंटल बेनिफिट है, नहीं है. सोसाइटल बेनिफिट है, इकोनॉमिक बेनिफिट है, नहीं. डेफिनेटली दिस इज नॉट सस्टेनेबल अप्रोच एक्चुअली. वी नीड टू रीथिंक कि हुआ क्या, क्यों हुआ और क्या करना है. मतलब ऐसे करके आप जाएंगे. मेटीरियल ट्रांसपोर्टेशन से, इनफैक्ट फ्यू डेज बैक वी आर अटेंडिंग सम मीटिंग. फ्यूल कौन सा यूज करें एक्चुअली, प्लांट के लिए कौन सा होना चाहिए, मशीनरीज के लिए कौन सा होना चाहिए, ड्यूरिंग कंस्ट्रक्शन कौन सा होना चाहिए, ट्रांसपोर्टेशन के टाइम पे कौन सा होना चाहिए. दैट इज ऑल्सो पार्ट ऑफ द सस्टेनेबिलिटी. लैक ऑफ कोऑर्डिनेशन. आपने प्लांट लगा लिया 160 TPH, आप टारगेट कर रहे हैं 1000 टन पर डे. पेवर रुक रहा है, चल रहा है, रुक रहा है, चल रहा है. दैट इज नॉट सस्टेनेबल अप्रोच. You have to really balance something. How do we do that? आपका राइडिंग क्वालिटी हो गया, रोड बन गया, राइडिंग क्वालिटी इज पुअर. That is not societal benefit. The users are facing the heat actually now. There are many things that you can think about actually that we are really defeating ourselves. And ऐसा नहीं है कि we cannot win those or we cannot really come over this actually. We can do something. So that's what we are going to talk about. That what are the changes that we have to bring in to not really plug or not really go in this direction actually. एक मैंने बहुत अच्छी इसमें चीज कही, आप देखेंगे पॉइंट नंबर 9, अनस्किल्ड मैन पावर, नो अपडेटेड वर्कफोर्स. मेरे लिए वो सस्टेनेबल है अगर मैं अपनी टीम को ट्रेन करके, या जो वर्कफोर्स है ग्राउंड के ऊपर जो काम कर रहे हैं, जो ग्राउंड के ऊपर काम कर रहे हैं, जो आपके पेवर हैं, रोलर्स हैं, जो आपके प्लांट्स हैं, जो आपके ऑन ग्राउंड स्टाफ्स हैं, दे आर द बैकबोन अगेन एक्चुअली. लिखने से काम नहीं चलेगा. वी हैव टू गो ऑन द ग्राउंड. We need to really train them. They are the people, they are going to bring the quality into the system actually. So I'm talking about the ground reality, how the system is, the things are working out. Let's talk about how do we bring the sustainability into the payment. couple of slides है, I will go very fast. First of all, अगर आप लाइफ साइकिल कॉस्ट देखेंगे, कोई नहीं चाहता कि उससे स्लाइड हो नीचे एक्चुअली. दिस इज अ स्लाइडर. कोई भी कॉन्ट्रैक्टर नहीं चाहेगा कि मैं ऊपर से नीचे स्लाइड होकर नीचे आ जाऊं एक्चुअली. और कोई भी ये नहीं चाहेगा कि जल्दी स्लाइड हो जाऊं एक्चुअली. आपको रहना टॉप के ऊपर है. लेकिन ऐसा नहीं कि सारी पेमेंट ऐसे बिहेव करे. कुछ एक पेमेंट ऐसा है कि फटाफट नीचे आ जाएगी एक्चुअली. किस अप्रोच को अपन डेवलप करना है, कैसे अपन करना है सो दैट वी कैन रिमेन ऑन द टॉप. फर्स्ट ऑफ ऑल मिलिंग एंड रिसाइकलिंग. अभी मैं देख रहा हूं कुछ टाइम से एक्चुअली लॉट ऑफ लाइक द पीपल आर एनकरेज नाउ एक्चुअली कि यूज करना है. बट अभी भी काफी कॉन्स्टेंट्स हैं. मतलब आप बात करेंगे अगर इंप्लीमेंटेशंस की, रैप इज नॉट अलाउड ऑन द बीसी लेयर, या फिर मुझे हायर रैप यूज करना है बट इज नॉट बीन अलाउड एक्चुअली, या फिर कुछ कंसर्न्स है कॉन्ट्रैक्टर्स के एक्चुअली. नहीं, हम यूज नहीं कर सकते बिकॉज देयर इज अ कंसर्न्स ऑन दैट एक्चुअली. द रीजन इज बिकॉज दे हैव द हेजिटेशन, बिकॉज दे आर नॉट कॉन्फिडेंट अबाउट इट. और ऐसा नहीं कि रैप इज फर्स्ट टाइम यूज इन इंडिया. ऑल ओवर द वर्ल्ड द रैप इज बीन यूज्ड ऑलमोस्ट मोर देन 30 to 40 years. थोड़ा सा we have to think about that, how do we implement that, and there are different kind of recycling process that you can think about actually. Whether it is cold wrap, hot wrap, and there are combinations, and there are many good machineries are now coming up. You can also pay actually while you are doing the recycling. दूसरी बात करेंगे preservation की. आप preservation, आपने road बना दिया, every 5 years overlay is mandatory. Road is excellent condition, nothing is required. And one of the project, SMA was there. After 5 years, microsurfacing was done. SMA is also damaged, microsurfacing also gone. Whether it is really required, how do we optimize that actually? Whether do we really need to make that kind of statement everywhere, or we need to just based on the really ground situation, based on some tools that we are talking about actually. So that's what we need to think about. Some of the additives are coming up. In fact, in India, we are really facing very difficult situation in terms of the performance. The premature failures are coming up sometimes. We need to think about the innovative additives that we are talking about. It can be anything actually. It can be anything that you can think about which can really enhance the life. Maybe hybrid PM भी हो सकता है, maybe waste plastic हो सकता है, maybe crumb rubber भी हो सकता है, maybe hybrid crumb rubber also actually. So we need to redesign our own system, that how do we come up with the innovative solutions. This is one of the important slides that you can think about actually. In fact, I was seeing the video today, it was played, like that, the kind of, and I was seeing we are proudly playing the video which is having the wrong practices of the paving. And I can really pinpoint those. We have not really touched the ground actually. We are talking about very hi-fi things, but if you go to the ground, and if you see the paving practices actually that we are really following, it's not really to the level that we really want actually. Segregation है, rolling practices proper नहीं है, आप define नहीं कर पा रहे हैं, कितना rolling देना है, क्या देना है, check नहीं हो पा रहा sometimes. Gas work is going on, and then बाद में आके देखते हैं तो thickness नहीं मिल रहा है, कभी density नहीं मिल रहा है, joints proper नहीं आ रहे हैं, riding quality maintain नहीं हो पा रहा है. There is not coordination sometimes. So these are the paving practices that we need to really put focus on those kind of things actually, and that is also part of sustainability. Alternate material, I will not go into the detail, but there are many materials that you can think about actually, many innovative materials. In fact, biobinders are coming up now. In the initial stage, but we need to think about that. There are many other things which is coming up nowadays actually. Innovative payment design, I really pay attention on that. And I'm pretty sure that many of the payment design, it has been done, I'm not quite satisfied on that actually. And that is the reason many payment designers don't come to us. Because I know the payment design which has been done in the DPR, the way it has been designed, it has been optimized, or it is designed in such a way so that it optimizes the cost. But how to compromise the performance? We need to really put focus on very stringent condition on that, what exactly should be designed as a payment, what kind of new technology has to be brought in to the payment design actually. And there are many good technology coming up nowadays. I'm not really thinking too far about the solar roads or self-healing roads. They are really, for the developed country, but let's talk about the reality on the ground that we have actually. There are many new technologies. In fact, Professor Ankit also touched upon. The MTV is there, FWD is there, NSV is also there. We have been collecting data, how to use them. What exactly is the benefit in terms of the collecting the data and then implementing them on the ground? कुछ है नहीं मतलब. कैसे करें उसको use? डेटा कलेक्ट करके डंप करना है या उसको यूज भी करना है, मतलब दैट ऑल्सो वी नीड टू थिंक एक्चुअली. Concrete, few slides on the concrete also. First of all, if you think about the concrete, water utilization is the main. We are not thinking about that. अगर आप concrete pavement की बात करेंगे तो आप you please estimate the quantity of the water which is required for the concrete pavement construction, and you'll be amazed to see that. कहाँ से आएगा इतना पानी actually? And we are also proposing concrete pavement in some region where there is no water. Forget about the aggregates, no water. Recycle water, can we think about that?
Professor, please conclude early.
हो गया बस. Plant and machineries, राइडिंग क्वालिटी इंप्रूवमेंट कैसे करें एक्चुअली, अल्टरनेट मटेरियल्स का लेना, डाउल बार्स के लिए जियो पॉलीमर्स है, अर्ली ट्रैफिक कैसे करना है, इंक्रीज पेमेंट लाइफ कैसे करना है एक्चुअली, एंड फ्यूचर डायरेक्शन. आई थिंक दिस इज द इंपॉर्टेंट स्लाइड ऑन द फ्यूचर डायरेक्शन. इफ यू सी, roller compacted pavement is also coming up now, and which is for the low volume roads that you can think about. CTB instead of DLC, how do you optimize the cost? Rehabilitation, which is going to be future actually. Again, many of the concrete pavement we are getting a lot of distresses. Riding quality has the problem, or maybe sometimes the distresses are there. What approach has to be taken in next 10 to 15 years? That we need to think now actually. And this is how I'm concluding my presentation. This is the complete summary, and after that I think I'm done. So we need to really put focus on the bringing changes in the DPR in terms of the how do we achieve the SD sustainable goals. Innovation, manpower training, creating fear-free environment actually. The implementation and ecosystem in terms of the industry, industry agency and the kind of agency that we have to do. So with that, I'm just concluding my presentation. Thank you.
Thanks, Professor, giving in-depth knowledge of the pavement and various technologies. Thanks a lot. Now our last speaker is Shri M.S. Rawat.
Namaskar to everyone. I'm the last speaker, and our members has told no EOT will be given, so I have to go as fast as possible. And my presentation is more introspective about what is happening in the highway industry, not a goody-goody kind of story. Few of the slides are a bit acidic also, but they are quite eye-opening. And perhaps we can do some correction in our highway industry. They are the topics I'm going to cover. The first one and last one is the most important. Other things I have to skip very fast. You see, there are three entities: employer like NHI, MORTH, or authorities. DPR consultant is a sandwich in between, and whatever he produces, that agency produces, that will be used by the contractor, and it shows how the successful with the project. Delay in project execution, we have discussed a lot because of the inadequacy and quality in the project preparation, whether we call it feasibility or DPR. It leads to the modification in main scope, variation, time overrun, cost overrun. Perhaps in last 5 to 7 years, we have heard our Honorable Minister Saab also that each and every meeting, every discussion, every conclusion goes and he attacks on the DPR consultants. Like entire failure or whatever unsuccessful is in the industry, that is because of the deficient DPR. No doubt the statement is correct. So these are the scope, collection of secondary data. I will not cover these aspects. Very detailed scope of work is there, very elaborated TOR is there, everything consultant has to do. I'll come to the straightway, the client's role and supervision in the preparation of DPR. I will summarize this entire slide, that whatever successful projects are there happened in the MORTH, in NHI, in the state governments also. Somewhere 80 to 90% the success attributes to the client. I don't say this is the sort of a contribution by the consultant. This is my practical experience. I attribute it to the client, and other way around also it is true. Again, I have repeated this slide because now we are taking a deep dive in the highway DPR consultancy. That's the reason I have repeated this slide here. Please give me just 5 to 7 minutes, that will be enough for me. This is the preamble, deficient quality of DPR. Quality of DPR for highway project is far from the acceptable level. The problem is not new, rather it is going on for last 2 decades. 10 साल से तो बहुत कुछ सुनते ही आ रहे हैं, इतनी मेमोरी हमारी है, 10 साल से तो बहुत ही सुन रहे हैं. During the last 5 years, quality of DPR has gone bad to worse. Fallen in severe vicious cycle, and all efforts being done by Government of India have gone completely waste. I'll prove it numerically also. Estimate that the deficient DPR quality attributes to the time and cost overrun of the tune of 40 to 50% of the scheduled time. During the implementation stage, just because of one reason we don't have the good quality of DPR, that becomes the 50% reason for that. The following few slides provides an eye-opening. You see, the DPR consultant is also a commercial entity. They have not come for charity. They have to do saving. And whatever kind of RFP we prepare it, whatever changes we do it, they will find out the loopholes, how to save money. It means it has to be a balanced RFP. It should not be a one-way RFP. But for last 10 years, sorry to say, it is being prepared one-way RFP. This has happened in last 10 years. I'm telling you the numeric numbers, how we are going back to worse. In 2014, I did not go much away from that. Char Dham Uttarakhand was quoted at 3 lakh rupees per kilometer. You see, many of the people don't understand what is the DPR, why this is happening. हर चीज की कीमत होती है, आप जितना अमाउंट उसमें इन्वेस्ट करेंगे उसके हिसाब से रिटर्न मिलेगी. 4 धाम 3 लाख रुपए पर किलोमीटर में था, भारतमाला 1 to 4 4 लाख रुपए पर किलोमीटर में थी. ये एवरेज कर रखे हैं, राउंड ऑफ कर रखे हैं, जिसमें लैंड एक्विजिशन प्लान अप टू 3D तक था. भारतमाला लॉट 4 के बाद रेट डाउन हो गए, 3 लाख रुपए पर किलोमीटर पे आ गए. 2020 में 4 लेन एक्सप्रेस पे 2 लाख रुपए पर किलोमीटर पे आ गए. 2022 में हम 1 लाख रुपए पर किलोमीटर पे आ गए और 2023-24 में हम करीब 1.2 पे हैं. अब सस्टेन कर गए 1 लाख रुपए पर किलोमीटर में. एंड प्लीज रिकलेक्ट इट फ्रॉम दिस पॉइंट ऑफ व्यू. इन 2016 और 2014 जब हम 4 लाख रुपए इन्वेस्ट कर रहे थे डीपीआर के ऊपर, तब भी हमारी क्वालिटी अच्छी नहीं गिनी जा रही थी. तो आज हम 1 लाख रुपए में क्या कर रहे हैं, ये अपने आप में एक क्लैरिटी दे रहा है. अब हम खर्च कितना कर रहे हैं हम डीपीआर के ऊपर, और वर्ल्ड वाइड हम कहां खड़े होते हैं इंडिया में हम डीपीआर के ऊपर. और देशों में ये डीपीआर की बुरी हालत नहीं है, वेदर यू कॉल इट डेवलपिंग कंट्रीज, अंडर डेवलप्ड कंट्रीज, इवन इन अफ्रीका or Middle East, don't talk about the Europe and other things, even they are not doing what kind of work we are doing here. Civil cost, let us say 60 किलोमीटर प्रोजेक्ट लेंथ है, 20 करोड़ रुपया पर किलोमीटर है. सिविल कॉस्ट 1200 करोड़ रुपए का प्रोजेक्ट अवार्ड करना है हमको. डीपीआर में क्या दे रहे हैं हम, 1.2 लाख रुपीज पर किलोमीटर, जो कि 72 लाख रुपए सिर्फ आता है. दिस इज हार्डली 0.1% ऑफ द सिविल कॉस्ट. एंड वी फील वी शुड develop a landmark project, signature bridges, signature projects, good expressways. This is the amount we are spending on the DPR preparation. As a layman example, we can take it like a DPR is a schooling, and when person goes to the colleges, graduation degrees, these are the construction. If schooling is not done properly, if the student is passed with a 35-40% marks, with a somehow is managing, then how do we expect that he'll be a good engineer, good doctor, good professional? So this is the kind of money we are spending it. This is the slightly I have shown what are the kind of deliverables. I have shown one arrow vertical left because it goes up and down, back and forth. 1 साल का प्रोजेक्ट 8 साल चले, 9 साल चले, 10 साल चले. मैं घटा के बता रहा हूं 10 साल, बिकॉज चल रहे हैं 2013 वाले, अभी 24 में चल रहे हैं, घटे नहीं है. तो 10 साल चल रहे हैं. ये जो एरो बना हुआ है इसमें घूमता रहता है कंसल्टेंट. लेमैन एग्जांपल में मैं बात करूं, एक टैक्सी हायर किया आपने, यहां से देहरादून जाने के लिए अमाउंट फिक्स हो गया, भाई तेरे को हम 5000 रुपए देंगे. मेरठ जाके रोक दी कि मैं 2 दिन बाद चलूंगा यहां से. वो कहेगा सर मैं क्या करूंगा, अरे तेरा कोई तेल थोड़ी जल रहा है, गाड़ी खड़ी है. सर खाना कहां से खाऊंगा, खाना घर पे भी तो खाता तू. गाड़ी रोक ले 2 दिन, हम 3 दिन बाद चलेंगे यहां से. फिर मुजफ्फरनगर रोक लेंगे 3 दिन, गाड़ी तो खड़ी है ना, तेल थोड़ी जल रहा है। सर कंसल्टेंट का सीमेंट और स्टील नहीं लगता, वो पेपर पे ही काम करता है, लेकिन अर्निंग तो उसे भी चाहिए। ये मैंने दो स्लाइड को ग्रीन में कर रखा है, रेड में कर रखा है। ये ग्रीन है जो हनीमून टाइम होता है डीपीआर कंसल्टेंट के लिए, उसे सिर्फ 30% पेमेंट मिलती है। चाहे आप उसे 5 लाख रुपए पर किलोमीटर कर लीजिए, आप 10 लाख रुपए पर किलोमीटर कर लीजिए, मिलनी उसे 30% है। जो नीचे वाला क्वेश्चन आंसर सेशन में आप ओपन है, यदि किसी को क्वेश्चन पूछना है तो। ये जो वर्टिकल एरो बना रखा है, इसमें बैक एंड फोर्थ होता रहता है 4, 5, 6 साल। और आप टैक्टफुली एक देखिएगा, जैसे मैं कह रहा हूं फेयर आरएफपी होना चाहिए, वन वे नहीं होना चाहिए यदि काम कराना है तो। सब में अप्रूवल इंसर्ट कर दिया यहां पर, आप देखेंगे द अप्रूवल वर्ड हैज बीन इंसर्टेड। अप्रूवल मींस it will never be approved, or approval means it will take 3 months, 4 months, or maybe 1 year. Earlier time it was on submission of those things. It means cash flow will be maintained, the person will get at least some money. How person will survive, how the firm will survive? We are looking it from one angle only. And very interesting part is that the 30th August 2021, all these points, same slides, almost same slides, our respected former members of us there, it was brought to the knowledge of highest authority, to the Honorable Minister of MORTH, in the media house of the MORTH. So the facts and complexity, just I'll brief it. Item number 4 to 10 takes 6 to 7 years. And EOT, it is surprising that EOT in DPR in India goes without any financial implication. उसके लिए भी एफर्ट करने पड़ते हैं। कोविड के टाइम पे सबको रिलीफ मिला, कॉन्ट्रैक्टर को रिलीफ मिला, अथॉरिटी इंजीनियर को रिलीफ मिला, क्या कंसल्टेंट को कोई रिलीफ मिला? 2 साल तो वो भी बैठे रहे घर पे, हार्डली 18 महीने तो लगभग फील्ड में कोई एक्टिविटी नहीं हुई। There was no consideration from that point of view. One of the main reasons of the DPR delay is numerous changes, variation. I should not discuss it more detail. Payment schedule always entail in a negative cash flow, and that's the main reason the consultant tried to avoid taking serious interest in the preparation of DPRs. Other things are written here. One DPR they prepared for, let us say it is awarded for 150 kilometer. Then they will make 5 packages. 30 किलोमीटर के, एक एक पैकेज 3-3 साल चलेगा, तो आप 10 साल से ऊपर समझ लीजिए। और जब तक वो 5 पैकेज नहीं होंगे, जब तक आपको कंप्लीशन सर्टिफिकेट नहीं मिलेगा। ये हम स्टैंड करते हैं वर्ल्ड वाइड, व्हेन वी गो टू एनी डेवलप्ड कंट्री और इवन डेवलपिंग कंट्रीज ऑल्सो, एंड देन वी कम बैक, व्हाई डोंट वी मेक दिस काइंड ऑफ प्रोजेक्ट्स, सच ए लैंडमार्क व्हाट चाइना इज डूइंग, व्हाट मलेशिया इज डूइंग। We spent hardly 0.5. मैंने आपको न्यूमेरिक नंबर में 0.1 दिखाया है। ये वर्ल्ड बैंक की मैकेंसी की रिपोर्ट है जिसमें स्लाइड ली हुई थी। एंड व्हाट काइंड ऑफ कॉस्ट ओवररन वी आर गिविंग 24%, वॉट एवर सैंपल साइज दे हैड टेकन इट, एंड वी फील वी आर वाइजर, एंड व्हाट अदर आर डूइंग, दे आर डेवलप्ड। नाउ कॉमन रीजन फॉर फेलियर ऑफ आवर प्रोजेक्ट्स, सॉरी टू से आई एम putting this word as a failure of projects. If 3-year project is being done in 6 years, so we cannot call it a successful project. If it is at 150% of cost overrun, we cannot call it a successful project. Deficient quality of DPR attributes the 40 to 50% magnitude to that failure. Land acquisition, change of scope, time and cost overrun. Allow on one item is 50%. If we hit it, it means we have got success, 50% success. Poorly drafted contracts. Sometimes whatever DPR has been prepared, but the draft contracts are not equally good. Inadequate dealing in handing over memorandums contributes to 20%. We are in a hurry just to hand over the memorandum. We don't prepare it detailedly. Lack of understanding. Aggressive bidding by the concessionaire, we call it as they are responsible, but it is hardly 20%. Still the magnitude is not that high. And client, consultant and contractor, instead of working in a cooperative way, work in a highly uncooperative way, and lack of trust is visible at every level. Perhaps we do the introspection, perhaps the statement you will find it is correct. I have given some suggestions. The duration of feasibility and DPR should be as per the scope of the work. If it is a 150 kilometer, even then it is 9 months. It is 250, even then it is 9 months. If it is a hilly terrain, even then it is 9 months. or it is a rolling terrain, it is a 9 month. There should be an escalation clause. Why that EOT is without financial implication? What is the wrong? We are spending 0.1%. Still the escalation, they are not giving it. So there should be a fix, no price index, other things. It should be a fix like a 10% per annum should be given, let it go then 10 years. Then client will also feel pinch at least, little bit. And invoice should be on not on approval, on submission. That the same color I have done it here. It should not be on approval. Site offices should not be asked to continue. That in the price bidding, the person has taken a 1 year office maintenance. The office is getting maintenance for 7 years also. MOM should be signed. Formal approval should be given. Key deliverable to be assumed deemed approved. I know they have more workload. Lot of the non-technical work has to do by PIU and ROs. But it should be deemed approved if it takes more than 15 days. The DPR should be approved in 30 days, otherwise it should be deemed approved. Maximum duration of any feasibility study or DPR should not exceed 3 years to 5 years respectively. After this threshold period, both parties should have the right for foreclosure after giving a 1 month notice, irrespective of the stage of the project. I'm sorry to say, whatever changes we are doing it, until unless we incorporate these 5, 7, or 8 points, perhaps we will not be able to improve the quality of the DPR. We can improve the cash flow. We can improve the strength of the consultants, but the quality will not improve. This is my understanding about this industry. And I understand the land acquisition should be given to a separate agency. That has been considered. Thank you very much.
Thank you, Mr. Rawat, for showing the in-depth information on the cost of DPR and other good aspect and bad aspect of DPR preparation. Thank you. So now I will open a forum for question and answer, only for 2 or 3 questions if they are not addressed, because we have very short of time. So any question? I think no question. So okay, now, okay, yeah, please. Please introduce yourself and then ask the question.
Myself, Ajay Kumar Ajay, GM NHIDCL Churachandpur. Sir, I want to ask one question, sir. Generally, after awarding the DPR, due to some political intervention, we used to tell him to do in this alignment. Afterward, we tell you, no, you go to the bypass alignment, then sometime greenfield alignment. So in this way, they are doing so many works on those 3 alignments, but we are approving only one alignment, that is the alignment for DPR, but we are taking extra work from him. And after doing the work, they are not getting the payment, and they are pretend to do the actual work. So we should think over these types of deficiency.
Thank you. At least you have some sympathy, some consideration for the consultant, and you have quoted a very practical example. And particularly Northeast region, the situation is very, very difficult. So thank you. That compensation should be there. And same thing I have repeated here, that there should be some clause. Every year there should be, there may be any reason, political reason or force majeure, every reason, any reason. But there should be a compensation or price escalation clause. Thank you.
The last question, because there is no time now. Yeah, okay.
Good afternoon. I'm Bhavin Kumar, CEO of Cube Highways. So my question is to the entire panel, actually. So when we think of doing a DPR, actually there's a lot of scope of work, and there is no clarity in the beginning. Sometimes you do not know even the alignment. So how a consultant would be able to assess the right cost, what he should bid? So I mean, what I have seen in the developed countries is they generally go with the framework contracts, where they have consultants on panel, and then they do a type of, say, first stage of the work. They will give you just alignment option study. And alignment option is frozen. Then they move to the next level. And then that time you have a better clarity that the alignment is frozen. Now we need to do the detailed design and or other things. So is there any thought in an HAI to go ahead with that type of model? And if not, why not then? Because I feel that the consultants are not in a situation to assess right quantum of work in the beginning when they do not know even the alignment or what type of tunnels, what type of signature structures are coming on the way. That's the one part. Secondly is the developed world is now moving towards BIM implementation. And I have seen the plan of UK, which they started in 2012, and their plan is to implement BIM level 3 by 2025. We have not yet started. So what is the plan of the government to move into that direction?
Yeah, your point is right. As pointed out by Mr. Rawat, that we are spending only 0.1% of the civil cost, and in developed world it is costing is around 4 to 5% of the civil cost, which is quite good for detailed investigation of DPR preparation. So, and now as shown by Mr. Padi, we are moving now towards the fixed cost consultancy, as said by the chairman sir also, that we will be around 5 to 6 lakhs per kilometer, not as 1 lakh per kilometer nowadays the DPR consultant quoting. And just to mention that in one of the case in NHI, the one consultant has quoted 50,000 per kilometer cost for DPR, and he got the contract because of the L1 and all those things. So that is the reason now NHI is going to switch over from that least cost to the fixed cost, so that at least we can get the required amount of work with detailed investigation, so that at least this 40 to 50% deficient DPR, which is affecting our project, can be eliminated. So that's we are moving towards that concept now. Thank you. So now with this, I conclude the session discussion. Thanks to all our panelists for giving detailed information on the DPR preparation. Thanks a lot. Thank you.
Our thanks to the esteemed panelists and the moderator of this session. Thank you for making it a very lively discussion. May I request you all to please join us front and center for a group photo op. After that stimulating discussion, ladies and gentlemen, we are quickly moving on to our next panel discussion. This is panel discussion 2, and it's on the theme Special Measures for Hill Roads. I request the esteemed moderator and the panelists of panel discussion 1 to please kindly join us back in the audience. Meanwhile, in panel discussion 2, our session moderator, the esteemed moderator, is Shri Atul Kumar, Director Technical, NHIDCL. The esteemed panelists of this session are as follows: Shri C.P. Ojha from IIT Roorkee, Professor Naveen James, IIT Ropar, Ms. Minimol Korula from Macquarie, and before we move on to our next panel discussion, ladies and gentlemen, we would like to share with you all that the nomination portal for 2023 National Highways Excellence Awards is now open. However, the deadline for applying for these awards is 15th of February 2024. Once again, may I remind you all, the nomination portal for 2023 National Highway Excellence Awards is now open. The deadline for applying is 15th of February 2024. We warmly welcome in our midst on the days the esteemed session moderator and the esteemed panelists for this session. Let's welcome them all with a round of applause, please. It gives me great pleasure to introduce them all to you. We warmly welcome the esteemed session moderator, Shri Atul Kumar, Director Technical, NHIDCL. He is one of the best-known names in the infrastructure sector of our country, having done his bachelor's in civil engineering from IIT Roorkee and then pursued an MTech in structural dynamics from IIT Roorkee. He has been serving the nation in various capacities since almost 2.5 decades, supervising and ensuring that the best standards of project management, quality, and accountability are integrated. A very warm welcome to you, sir. We warmly welcome Shri C.P. Ojha from IIT Roorkee. He is the Distinguished Professor at the Indian Institute of Technology, Roorkee, specializing in hydraulics engineering. In 2022, he was recognized with the ASCE Research Paper Award by the American Society of Civil Engineers, highlighting the quality and impact of his research contributions. In 2021, he received the Jal Vigyan Puraskar from the Indian Society for Hydraulics. We warmly welcome Professor Naveen James from IIT Ropar. He is the Assistant Professor and accomplished researcher in the Department of Civil Engineering at the Indian Institute of Technology, Ropar. He earned his PhD in Geotechnical Earthquake Engineering from the Indian Institute of Science, Bangalore, and then served as an Assistant Professor at the Birla Institute of Technology and Science, Pilani. A very warm welcome to you. We warmly welcome in our midst Ms. Minimol Korula from McAfee. She is the Head of Strategic Initiatives and Projects, McAfee Environmental Solutions Private Limited. She has more than 20 years of experience in introducing and educating on new technology, polymeric and bioengineering material. She has also unique opportunities to get involved in challenging projects of the nation in the domain of slope stabilization, riverbank stabilization, etc. May I request all the esteemed panelists and the session moderator, in keeping view the limited time at our disposal, to please kindly keep your interjections as brief as possible. I now hand it over to the esteemed moderator of this session. It's over to you, sir.
I will take a minute to load my content. सब इशू इधर इशू आई विल कहाँ से ओपन हुआ नहीं इसमें नहीं इसमें कुछ इशू है इज वन प्रेजेंटेशन हाँ नहीं आपने कुछ किया है There appears to be some difficulty in the presentation loading. So I will just introduce the topic from my end. Almost 42, around 8 states of the country, they are the hilly states, and around 42% area of the country is falls in the hilly states. The problem in hilly state is mostly because of its unique
configuration that the terrain is specific, the altitude is specific issues, and mostly the landslide, sinking, such type of the issues. If we see the scenario in the whole country, then the temperature in the whole country, it varies from around minus 45 degree to 45 degree plus side. And the hilly states, it's specifically the lower temperature we have to work upon. In hilly terrains, the biggest problem is the landslide. And today with us, the experts are from the community, which can address the issues of the drainage, which is a issue related to the landslide, and prediction of landslides, as well as the successful measures to be taken in the landslide areas. So these are the things which our experts are going to present. They are from the expert areas, and they will be presenting it. So I will first call upon Professor Ojha for his presentation.
So hello everyone. It's a pleasure to be here, and this is any first conference on highway engineering in Delhi that I am attending. I have many friends in highway engineering. We have many renowned colleagues at IIT Roorkee who have worked as directors CRI. And when I meet them, they said that, oh, you are the man we are afraid of. Because my core specialization is hydraulics. And whenever there is any drainage issue, any drainage problem, when the water comes in contact with the road, it's not a pleasant situation. So just to begin with, the focus of this particular theme is on drainage. Recently I was approached by NHI. Sri Pandey ji is here, R.K. Pandey, and we paid a visit to Mandi Kullu Manalu highway. And the kind of damage which I could see there, certainly I had to realize that a lot needs to be done, and hydraulic engineer as well as highway engineers, they need to come in close collaboration to solve these problems. Now many a times, now the climate change is taking place. We talk about climate change, we talk about cloudburst, where we think of rainfall intensity somewhere of the order of 300 to 400 millimeter per hour. That's the kind of intensity we are talking about. When you look at IMD records, the intensity at many places will be much below this. Now, the drainage plan which we developed, the first important step in that is that what that critical intensity should be. And so, for that, there is some formula which depends on time of concentration. Now, when it comes to the computation of time of concentration, I will show you one particular slide where you'll see how it is very difficult to compute this accurately. And so there the problem starts. The second problem is that because of this high intensive rains, the rivers will carry flow, and the flow velocity will tend to be very high. If such high velocities are not tackled, this will create damage to the banks bed, and if any road is aligned along these banks, then that damage will take place. And this is precisely what happened to this Mandi Kullu Manali highway. At many stretches, the road, which is just adjacent to the river, has been damaged, and so much loss to the road has taken place. So all these concerns are really important, and we can see some of these photographs. They're just compilation, right? And the blame at once goes that there is something wrong with the hydraulics of it, drainage part of it. But in the morning I was listening to some of the experts, And so now I can talk to my friends with more clarity that, look, I'm not always to be blamed, right? Hardal is not always to be blamed because a proper science is there, and if that science is followed precisely, then a lot of problems can be avoided. Now, because of this intensive rain, we can see that, this is the analysis of, Satluj Basin, and we can see here that how the extent of erosion from different parts in the catchment can vary, but the most important part in this is that it strongly depends on the rainfall intensity. The more the rainfall, you must expect more sediment load to come into the river. So that's guaranteed. There is no denying fact about this. And when we talk about cloudburst, it's an entirely different story. I'm not going to touch that at this stage. This is how the riverbank instability becomes. You can see a simple bed, and you can see how, because of this movement of water and this changes in the bed form takes place, and just some of the sequential developments of this one shown in this figure. Without going into this, you can see the real life photographs where you can see some depositions on the banks, nearby banks, and the flow is not taking place uniformly in this one, right? So if such is the behavior of flow, why it is happening? Because if some sediment load comes into the river and river is not able to transmit it, to carry it safely, then it will deposit this sediment, because every river has a sediment transporting capacity. And if it is exceeded, it will just deposit it. If the sediment transport capacity is higher and the load is carried is low, which is rare the case, then the river will try to again erode the bank, it may meander, so all these problems will take place. So with this change in form, we were fortunate to be given one project by Border Road of Organization, where we looked into bridge scour in hilly terrains. One was Dhundi Bridge, just close to Atal Tunnel, and other 3 bridges, Pasighat Bridge in Arunachal Pradesh. So these are some of the photographs of this one. And we are just asked to find out that at some places there was excessive scour, and why it happened so. Now excessive scour depth also depends on what kind of velocity we have. If the velocity tends to be very high, this will lead to higher value of scour, right? So that's a very well established fact. And lot of vortices formations around the bridge piers will also take place. In nutshell, we try to use Lacey theory to estimate scour, but Lacey theory is not applicable because it was developed only for alluvium. So if you try to use this theory at other places, this is not going to be correct, and particularly in hilly regions, when we talk about the development of a suitable model, so we try to consider all these 4 bridges which were given to us by Border Road Organization. We developed the scaled model of this one. We try to look into the possibility that what kind of maximum velocity we can get it, and how the scour depth is related to the velocity. So these are the typical photographs, just to give you a feel of how does Arunachal Pradesh look like, and how the Dhundi Bridge looks like. Some typical photographs are given here. So you can see here that these are the characteristics of the bridges, which I am not going to highlight here, but details are given here in this PPT. So the scour depth in this case was studied by constructing the models. And by constructing the models really helped us to see that how this scour is related with the velocity in terms of a critical velocity threshold. So it's not that directly you multiply this velocity and get the scour depth estimation. So this is the one work which we did, and I thought I should highlight you. This is already submitted to Border Road Organization, and it's approved by them. Okay? So this is the new work which is proposed. Now, river training work, when we talk about, there could be several options available. And it's not necessary that only one spur will work, but we can go for a series of spurs. We can also think of using gabions, but when the velocity is very high, we have to really go for, so this is some of the work which we are doing in straight and curved bridges, and this can be translated into the field. Now, this one I also wanted to highlight. You normally talk about the flow from the road to go by a culvert, and it falls over the steps. Now, there is the real problem, because we have seen this at many places, that the damage to the road has taken place because of this one. Now, what we expect is that this flow will move smoothly over these steps and certain dissipation of the energy will take place. But you see, there are three types of regimes. One is in which the flow directly falls over a step, moves again, it goes to the another step, and this is known as Napier flow. In Napier flow, the energy dissipation is maximum. But when the flow is more, when the drainage is more, because of this climate change, heavy rain, then you see a situation, different designs of this one are given here. Now, I'm not going to talk about the mathematics of this one, but considerable amount of work exists to know that how much dissipation of energy will take place. Now, this is the way, the water falls over different steps, and after falling over different steps, we can compute the energy from this equation that this type of culvert will lead to so much loss in the energy of the coming flow. So this is very important. If we do not give proper attention to this, then the residual energy will be more, and this will start, damaging the things. And this is one of the very important cause of this one. Now here you see the flow in the lab, where you can see sometimes when you try to increase the flow, the velocity is so high that this jet does not directly impact the step. So it means the step which you have provided there without any due consideration, that becomes meaningless. And so the residual energy which remains after these steps, now that still remains significant to damage the road. So this is the kind of which we have done it. And such type of, steps are provided at many places, not only in India, but other places also. So we can think of these modified designs of steps, that how these steps can be designed so that the culverts, if the flow from the culverts is allowed to flow over such designed steps, then the damage to the road will be minimized. So this is what I wanted to highlight. Now, here you see we had a typical situation. The project was sponsored by NHI. I thought I must include it here. This is also a stretch in which the velocities of the order of 10 meters per second were obtained. And so the Chakki Bridge in Pathankot, and they approached us to find some solution to it, that how such high velocity flows, and why this happened, because in the river, the sand mining was going on. And what was happening, that when the high velocity flow was coming into the river, this sand mining, the mined sand, the pit hole was moving upward, right? Because when the jet is falling, it is trying to erode this. So this sand mined pit started moving upward. First it damaged the railway bridge, and after that, it started affecting the, this roadway bridge. So this is what happened. NHI was going to do construction of another bridge there. So again, this was the risk involved there. And so just looked into it, and it was the typical case of high velocity flows encountered even in the river bed. So we tried to minimize this impact, and you see certain steps have been provided here to dissipate this excessive energy. So that's the way we try to address this problem. Now, this is the one typical problem related to drainage, which we are doing at the Pitkul Srinagar site. I'm associated with this one. Now, this power grid, the power station is built on several terraces, right? Sometimes the cutting is there, sometimes the filling of fill is there, and lot of damage to this one has taken place because of this intensive rain. So this erosion of this one, then collapse of the retaining wall, all these problems, the damage to the roads, this has, taken place at this particular location. So I was approached to address this problem, and see, this is the typical drainage plan. Now, this is very important, because normally we have the perception that drainage will come from only one outlet. Now, that's our perception. And we try to compute time of concentration. We just try to pinpoint that particular outlet, and we try to compute the time of concentration. But here what we have done, there are several outlets. In this one we have provided, and that's the way we have designed it. And it's not only that we have identified these outlets, but we have also precisely pinpointed that how much flow will come from each outlet. So any drainage plan, if you are trying to develop, the first important thing is that you must try to identify that what are the possible outlets. Unless you identify these outlets, you cannot precisely pinpoint what is the time of concentration. If you cannot do that, you cannot precisely quantify what is the intensity to be considered, and so your entire drainage plan, which is being developed, that will be, need to be revisited. So I think these are some of the important considerations which I wanted to highlight, that it's very important that we should work together to solve some of the challenging problems where the high velocity flows are encountered, where there are drainage issues in the roads. So by considering all this, here we have considered different types of trench drains and traps and drains, surface drainage. So all these options are considered here. So this will lead to better solution of the drainage problem. So with this, I think I would like to conclude here and say thank you very much for your patient listening. Okay.
Thank you, Mr. Oja, Professor Oja, for a great insight into the science of the river silting and erosion control and drainage patterns. I have one question before you quit the dais, sir, because the topic is related to challenge in the hill road construction. We face a problem whenever we construct the hill roads and cut the hills. The subsurface drainage, it gets disturbed. And disturbance of subsurface drainage, it creates a lot of things and which lead to further some landslide issues also. I would like to understand, or we would like to understand, that what may be a good approach for managing this situation of disturbed subsurface drainage and restoration of it.
Yes, I think this drainage issue was also raised to us when I think we are going for this construction of near Pando Dam. So that issue came at that time. Its first important step is that we must identify that when the precipitation is taking place, what fraction of it is infiltrating downward. That's the first part we have to understand. And how much it is coming as a surface runoff. So for this, the first requirement is that we have to go for infiltration test. That will give basically the idea of that how much water is infiltrating. The water which infiltrates, that have to be, properly tackled through chimney drains. Provision of chimney drains, I think, minimal will also show that particular slide. So I think this is the way. Otherwise, at surface runoff, we have proposed trench drain and all those things. All those options are there. We can trap the surface runoff itself and divert it through culvert. So these options are there. So I think they should really help. Yeah.
Thank you, sir. Okay. I would now call Dr. Naveen James. He is Assistant Professor IIT Roper. He specialized in dynamic behavior of soils, landslide, hazard assessment. He will speak on the prediction of landslide susceptibility for the Himalayan region. And the topic was given to us, challenges in hill construction, and understanding that every case of landslide or sinking or something, it's a unique case. Normally we are dealing all the cases put together in one basket and putting up some cut and paste or copy paste measures of selected guidelines. But the time has come then we have to deal with all cases uniquely. In that case, the type of the science or type of the information which is being provided today, it may be a lot of useful. So Dr. James will provide on the prediction of landslide susceptibility and its related measures. Sir.
Thank you. Thank you, Atul sir. I thank MORTH for inviting me and delivering this presentation. So as Professor Oja rightly said, the contribution from water resources engineers in highway constructions is increasing, and especially in the hilly regions, the contribution from highway engineer, geotechnical, geomatics, and water resources experts are pretty much required because the problem is very complex. Even though we say landslide, undercutting, flooding on the hillside looks to be very simple, but it's very complex because of the heterogeneity in the terrain and also the climate change. So as Sir rightly said, typically when rainfall or precipitation occurs, some part of it goes into the soil, infiltrate into the soil, and comes out as a subsurface drainage. And when the quanta of rainfall increases considerably, like in case of a cloudburst, the infiltration, the quanta of infiltrated water will be more, and thereby there will be more seepage and causing the instability to the soil slopes or rock slopes. So here, what I'm going to present is predicting the landslide susceptibility, especially for the Himalayan region. Now, here, a susceptibility mapping is something like Lakshan Shastra. We look at the terrain type, what are the rainfall conditions, etc., and we say that whether there is a chance of landslide at that location or not. At this point, we do not go into deep mechanics. We're not going to do a slope stability analysis or slippage analysis because that requires extra knowledge of the soil subsurface information and the infiltration analysis and slope stability analysis to be done. That requires that's a tiresome work. But a quick way to determine whether a region is susceptible to landslide can be done using a GIS-based landslide susceptibility mapping. Now, typically we know that a landslide occurs when driving forces exceeds the resisting forces. And typically we see in Himalaya, these driving forces are mainly due to the rainfall, the excess rainfall. And due to the climate change, now this trend, the pattern in the rainfall is changing. Not just the amount of rainfall, like it's also the duration. Let's say if 100 mm rainfall happens in 1 hour, it is critical for this loop. So we should know, like when we are going to understand about the stability of highways or roads in the hilly region. So susceptibility mapping will give us zones where the chances of landslides will be high, and coupled with the correct information about the hazards, we can know the its spatial and temporal distribution in the region. And once you have a susceptibility map, you can devise policies. The DPRs can be that can be incorporated in DPRs while for any projects. So yeah, so already we have a very primitive landslide zone map given by NDMA, but nowadays so many studies have been done to quantify this landslide susceptibility mapping. And typically we see this figure, like a highway is constructed, and suddenly after a monsoon season, tremendous resources will be employed just to clear this highway, make it work after the landslide, after the occurrence of landslide. So similarly, you can see these are the landslide happened not just on August 2003. It's in previous years, and this is a typical landslide happened in a Solda village in Himachal Pradesh. So you can see that, especially after the major rainfall of August 2023, you can see how much the run-out distance that has covered, and the entire village was affected because of this landslide. Now, susceptibility mapping, there are several methods are there. We broadly classify into qualitative, quantitative, semi-quantitative and quantitative methods. But what we do is the causative factors that we look upon. So we look at the lithology, slope, land use, land cover, hydrological conditions, and the derived parameters. So these things we can obtain. So especially the slope map. So nowadays we have terrain models are there. ISRO themselves have provided us the digital terrain model, a digital elevation model, Cartosat DEM. So those things, from those freely available DEMs, we can develop the slope maps, aspect maps, then drainage, distance to road. Now we have road maps are there. We can use it, overlay on this DEM of the study area. We can get the distance from the road. And all those parameters, we can find it out. We have Landsat data available from which we can develop the land use, land cover map. Like, it's not just the how the land has been used, whether the land is being used as an agriculture, it's a forest. It all has implication in susceptibility mapping. I'm not going to discuss details about the different methodologies. So basically what we did is we took all these parameters for Tehri region. Basically Tehri, we have a lot of data available. So from Roorkee, IIT Roorkee also, Professor Ambalagan has also quite extensively worked on that area. And the extensive landslide data are available. So we took this landslide data and then we took these factors such as the rainfall map, the soil moisture map, then from earthquake data we get the peak horizontal acceleration maps, and then we use algorithm, ANN algorithm, to see how these maps or how these data are correlating with the landslide data which we obtained from the past. I'll just come to the point. So we could find out 11 major parameters are there that if we know, we can find out the susceptibility mapping of a particular region. At this point, I'll just restrict to Himalayan region, whether it is valid for Western Ghats or Eastern Himalayas, that need to be checked. But for the Northern Himalayan region, it actually works. So major ones are, I can see, is slope, distance to a road, rainfall, TRI, land cover, soil permeability index, stream index, etc., etc. And then we prepared a susceptibility map, and then we lands out of 100% 100 landslide data, say 70% has been used to train the model, and 30% we use for validation. So when we check with the validating data, we see that most of the data are falling in the high susceptible zone. And similarly, we prepared a map for Himachal Pradesh, and we collected the data from 2019, landslide data from 2019. And we could see that most of the data are falling in this high landslide susceptible zone, that is red zones, basically. So it's a simple exercise. Now, if we know the parameters, we can prepare the susceptibility map for any region, and our alignment and it can be incorporated if it can be incorporated in DPR. I think that would give much more better planning of highways or construction of highways, especially in the hilly regions. So now other works we can look at is the future projections. So there are climate change models are available. So there we need to have an expert from water resources side to help to give us the projected rainfall in future scenarios. So if you know the projections in future scenarios, we can find out the future landslide susceptibility mapping. And one of the important thing about the hilly roads, like I hear from contractors and all, is the restriction of ROW. So what we have proposed to NHAI as well, at the DPR stage itself, we can do if we know the alignment, we can actually optimize using GIS and slope stability analysis, incorporating both with few ground data, geotechnical data. We can optimize the ROW. Not everywhere we need to give a very high ROW, but the locations where it is critical, we can go for a higher ROW, and that can save a lot of cost, especially in future, and mitigate landslide at that location. Okay, with that, these are our publication that has come, and thank you very much.
Thank you, Dr. James, for your presentation on landslide susceptibility and its possible uses in the highway designing and construction also. Thank you, sir. And now I will invite Ms. Minimal Karula, Head Strategic Project and Initiative, Ms. Mecca Ferry. She is specialized in landslide, slope stability, mining and ground improvement, and to speak on the need of flexible, free draining and eco-friendly structures in hills. Please.
Good noon. I'm really honored and humbled to be here. The topic is the special measures, and especially from my side, the flexible, free-draining and eco-friendly structures, in which area I am working most. So the challenges in hilly terrains, when we talk about landslides, it's not just some slopes instability or some hill is slipping. That's not. Especially when it is coming to our Himalayas, the landslide is in various forms. It's starting from just erosion problems, then the landslide itself, debris flows, rockfall, avalanches. So various forms are there. So definitely a single standard recipe is not there. It requires the very precise understanding as well as the analysis approach, and finally practical and feasible construction methods. At the same time, when we are talking about standardization is difficult, some way we have to standardize also, because at this point of time, kilometers and kilometers, the hill road construction is going on. So with every 100 meter, we may not be able to really go for site-specific approach. So wherever standardization is possible, it need to be standardized, but at the same time, the site-specific approach also has to be there. So the hilly terrains in India already, this was being discussed. We do have different mountain ranges, Himalayan, Western Ghats, Aravalli, which are having very diversified geological and geomorphological characteristics. At the same time, there are common threads. We can see that in almost every places, some common solutions also can be applied. Now coming to the guidelines or the state-of-art reports or codes which the ministry and IRC published, if you're seeing everywhere, some common traditional approach is there, and which need to be taken in certain cases, like avoiding and eliminate the problem itself, then use of lightweight materials. These are being mentioned in some of the codes or guidelines which is published 20-25 years before, but which lightweight material, that is not outlined. But nowadays we know we can use maybe fly ash, we can use synthetic materials like geofoam, but we need to look into that more. Modification of slope geometry is something where space is available, which can be done effectively, but everywhere it may not be so much flexibility and freedom we will not get. Now, everyone will agree, as Oja sir said, that the water, which is essential for life, but when it is coming to the highway construction, water is one of the first villain, which can cause the landslides and slips unless we are not channelized, unless we are not understanding and making the real measures. So surface and subsurface flows, the first itself, it need to be understood clearly how much the rainfall up to the infiltration. So that concept has to be there from the DPR time onwards. And for the surface measures itself, we know our Hill Road Manual, the previous version as well as the recently published version, it's talking about the different type of surface measures, whether it is roadside drains, whether it is catch water drains, intercepting drains, or at the end, the outlets, maybe through a number of culverts. So these network need to be planned and tailored from the planning time itself. Maybe we can, the retaining wall or the river training works, we can postpone it, maybe the implementation time. But the drainage, unless we are not doing in the planning stage, it will be very difficult. Recently, when we were doing a particular, the slope stability problem, after the construction is after 80%, we had to suggest that please insert horizontal drains somewhere here, which is very difficult. We know that we can just suggest it, but it cannot be implemented. And Oja sir already said that, and even Professor Naveen also. So from the planning or the DPR time, the determination of the rainfall data, catchment area mapping, the peak runoff, finding out it hydraulic design, all these are outlined in our IRC SP 42. But when it is coming to the hills, a more practical approach, that is not getting outlined. Maybe the H4 committee is now revising the IRC SP 42, and I hope that it's really getting covered. Now coming to the flexible systems, that's my highlight. The reinforced soil system in the inaugural session itself, I was so happy and excited to hear that reinforced soil system is now accepted as a very practical technology. But at the same time, when we are using the reinforced soil technologies in hilly terrains, there are certain very relevant aspects are there, because the most common or popular, every cities and every towns, even small towns are having the reinforced soil wall with a concrete panel or segmental block. But can we do it in hilly terrains? It's very difficult because you require a crane and all. So in those type of places, we may have to go for, we can go for reinforced soil system, but we may have to go for the suitable type of fascias. The fascias may be the vegetation or vegetated fascia, like steel wraparound systems, or it can be with the gabions. And while we are going for these type of fascias, it's the adaptability and durability need to be seen. And another aspect is that for the MORTH is talking about a number of reinforcements, but the most popular reinforcements are the steel strips, as well as some steel meshes and the geogrids. So the steel is very effective and it is the most proven, whereas the geogrids are having uncertainties. Its creep values we have to know, damage factor we have to know, a lot of material factors we have to know. But the feasibility point of view, the geogrids are better because it can be easily placed. The rods can be easily placed, especially if it is a tall structure. Now coming to the different type of materials, it's very important for the hilly terrains if we can minimize the transport. We were talking about carbon footprint. The moment we are bringing from distant places, the whole economy will get messed up. So the two major aspects which can help for the cost economics, one is use this material which is available in the site. If from the hill cutting, whatever the material which is coming, if that can be used maximum, whether the boulders or the fill, the morning time we heard that for the reinforced soil, 5 value 32 is required. I do have the correction, we can modify it. And reason some of the codes are telling that good news also. But as far as possible, if we can use the material which is available in the hilly terrain, that will be helpful. Second, we can use some factory produced materials like geosynthetics. Instead of going for gravel drains, in places where gravel is difficult, we can go for geosynthetic composite, drainage composite. And in some places, it will be very difficult to do the excavation, but at the same time, the slope may be requiring protection and stabilization. In that cases, whatever the meshes or gabions or whatever I told, instead of going for an excavation and placing geogrids and all, we can go for nailing or anchoring or bolting. But here also, a careful evaluation, whether we have to go for a complete, a global stability approach, or we have to see that how the infrastructure can be protected for some time, because the global stability approach may be requiring 100x as the cost. Whereas with the 10x, we can ensure that the infrastructure can be protected for some time. So now coming to erosion control measures, I feel that vegetation is the simplest and the most effective type of preventive method for landslide mitigation, provided that the place has to be favorable for vegetation, the slope has to be gentle enough. If it is less than, say, 45 degree, let us go for vegetation if we can make good species, durable species there. But when the slope is more steep, then we may have to add some tension elements there, because if we are hanging just a vegetation there, it may not survive. Then we may have to bring a medium. That can be starting from our coir or jute or such bioengineering methods, or maybe for very steep slope and very tall slopes, we may have to add a higher tension elements like steel or geogrids. Now coming to the rockfall, so this is an extract from one of the state of art. So many methods are there. It can be a barrier like a passive method, which is not stabilizing anything, but still protecting the infrastructure. Or it can be some drapery systems with a combination of meshes and nails and all. Or it can be a combination of drapery and barrier, like an hybrid system. Okay? So the cross section what you are seeing, it is from Mumbai-Pune Expressway. So in the Mumbai-Pune Expressway, many of the systems are already being used. But I will say that the most effective method which has stabilized the Mumbai-Pune, the rock surface, that is in fact the subsurface drainage pipes, which has incorporated in this stabilization method. Now one more is tunnel portal protection. When the site visits happened for the Himalayan stretch, Himachal Pradesh stretches, I realized that a lot of slope stability problems happens where road tunnels, especially the tunnel portals. So all the systems, whatever I have described here, that may have to be applicable in a tunnel approach, provided that a correct analysis is there and the subsurface drainage pattern around a tunnel need to be understood at that time. So now one more aspect, the studies are important, but at the same time, the monitoring during the construction as well as post-construction, because most of this, I'm talking about specifically flexible structures. So these are like organisms, living organisms. So they can accommodate more movements, but there is a limit. So, but the instrumentation or monitoring during the construction as well as the post-construction, that may be really giving a lot of insight on the performance, as well as it can really prevent the future disasters. So the pore water pressure can be measured by piezometers. The strain gauges and pressure, earth pressure cells can give the idea that whatever it is predicted at the time of the design, whether it is the same or whether it is exceeding. And if we are having a feeling that there can be movements in horizontal direction, we can have some reflectometers which are more cost effective, or maybe some inclinometers, but all this has to be decided in the DPR time itself, because it also having not only the involvement of cost may be affordable, but if you are not incorporating in the beginning, it may not be incorporated later. So some glimpses of few case studies. Mumbai-Pune Expressway I already mentioned. It's a combination of different type of system. It's not just one single system or anything. So number of the codes and guidelines are there for different types of landslide mitigation systems. But when it is coming to the rockfall, Mumbai-Pune in 2015, 4 people died just because of rockfall. So, but the codes and guidelines which are available for rockfall protection systems, it is few. In the BIS only is having only 3 codes which is talking about the rockfall protection systems. So that is some lacuna which need to be, I hope that it may be rectified within the next few years. This is a small gabion structure in Kerala near Kudiran Tunnel. And this I felt it can be highlighted because this had to be constructed within 10 days. And they were able to do that because gabions were available in a nearby site. So the point is that in this type of areas, where landslide prone areas, the material availability has to be there some way. Then we can do the things, even if it is not the best design or best analysis is not possible, still the material is available, it can be done very quickly. This case, within 15 days, they have restored the traffic. So these are 2 projects which are really, I would say, very complex slope stability problems. One is in Nepal, our neighboring country. It's a fast-track project for the army. So you can see that the construction was going on, that the photo is from there. And it is, in fact, you are seeing a gabion fascia, but it is a reinforced soil structure. The reinforced soil structure, the slope is almost 25-meter high, and the reinforced soil structure with the drainage system, that has given the solution. In the right side, it's an Indian project. It's in Uttarakhand. And here, the construction is completed, and the vegetation started coming as the erosion control. So it is a retaining wall plus nailing plus erosion control. That is the solution. So the Uttarakhand project, whatever you have seen, that was only a part. This gives more. So there is a road which is going, the valley side is there, the hillside is there, and a river body is there. Okay? And if we take the complete overall stability, from here only I told you that it may be 100x, maybe the cost. So in this case, it is rectified. The slide which has happened because of the choking of nearby culvert, that is rectified, and the complete protection and stabilization was ensured. But it is not about global stability. Whatever you are seeing in the riverside, there is a protection system. Then the valley slope, that is protected with a number of reinforced soil structures and a series of culverts. Series of the drainage systems. And then the hillside is protected with some meshes for the rockfall drapery systems. Okay? So the same, I think more clear illustration is there. So I'm just skipping. This is Himachal Pradesh. Again, a reinforced soil systems. Here you can see that very different from the normal reinforced soil systems. In normal reinforced soil systems, we have to provide 0.7 times the height. But what you are seeing is a 28 meter high structure, but you can see the base width is quite less. The reason was like that. In the initial design, it was almost double of it. But the excavation was not possible. It was a hard rock. So it has really changed. The base width has now the minimum, and the top width is more. And this is permitted by the code. Code is permitting that. So a specialist has to work in such type of regions. Now coming to the last slides. So even in Himalayan states, in some places we have to find out solutions for avalanches, and we may have to do emergency protection systems. So nowadays, such type of systems are there, like umbrella systems, which is combining the nails and meshes together. So we can adopt those type of systems once that is inside our codes also. Again, H4 committee is hopefully publishing a guideline, which is called the slope guideline, that is covering these umbrella systems and all, and hopefully we will be able to use it. And this is another structure, another stretch for BRO in Arunachal Pradesh, where the umbrella systems are being used. Now, always we talk about there is no guideline and guidelines for landslides, as well as its investigation, as well as implementation. But I can show a lot of big list where state-of-art reports are there, guidelines are there, the material specifications are there. Not only the IRC and MORTH, I have taken few from the BIS and ISO, because India is a participating member of ISO. If ISO standard is there, we cannot tell that we don't have standards. Okay? So my 3 slides are fully the list of the guidelines, as well as the state-of-art reports which are relevant for the hill road construction. Recently, the hill road manual is published by H10 committee of the IRC. So if we want to understand about what code says, how to do the investigation, how to select the materials, how to do the construction, and how to monitor it, there is enough things. The problem is, most of the time, we are all not having the time to read and understand what it is there. And maybe perfection is required and more refinement is required, but definitely the guidelines are available. So concluding here, I discussed about some of the calamities in hill roads. The drainage is having the very high significance. Few case studies highlighted. Hill road requires definitely a multidisciplinary holistic approach. And the solutions need to be free draining because water is the problem, water is the villain here. And all drainage measures need to be designed from the catchment area calculation up to implementation stage for surface and subsurface drainage systems. Flexible structures are better compared to rigid solutions in different ways, especially in landslide prone areas. The solution components should be eco-friendly as far as possible. Okay, let us think about carbon footprint and all while we are formulating the solutions and implementing them. There should be options of emergency solutions, ready-to-fix solutions in a landslide-prone area. Because any geotechnical engineer who dealt with it, they know that once a landslide-prone area, it will be always having the chance of getting the slides, the repetitions. The post-construction monitoring is highly recommended for critical stretches, and codes and guidelines are available, and definitely let us implement it. Thank you.
Thank you, madam. Before you leave the dais, I just have one question, that what is the cost effectiveness of these flexible structures over the conventional structures?
Yeah. Sir, see, it will be cost effective in the perspective of it can accommodate more movements. Because in the landslide area, more dynamic forces are there. Either the slides are happening due to the dynamic motion of water, or it may be due to the tectonic or seismic activities. So if you compare for rigid structures and the flexible structures, the design principles are almost the same, only a little difference in the materials type and all. But the limits what it is allowable for rigid structures, for example, for a retaining structure, RCC structure, what it is permitted is 25 mm to 40 mm, the movement. But for a flexible structure like a reinforced soil structure with a flexible fascia, it can change from 100 mm to 300 mm, okay, provided the structure above it is okay. So this will bring a lot of cost changes, especially where subsidence is there or lateral movement is there. Normally, the type of the cost comparisons, whatever I have seen from the contractors, it varies between 30% to 65% because of the fact that you can reduce the embedment depth as well as you don't have to restrict with the 25 mm and 40 mm. So that's it, sir.
Thank you. The second is you have spoken about the instrumentation and its monitoring.
Yes, sir.
How long we have to do it?
Okay.
Does it have some timeline specified, means the measures they have settled, and we should close it or continuously monitor it?
Yes, sir. So this is some question which I think the last 4 or 5 years repeatedly I heard, and I won't be able to give a one-word answer again here. See, sir, most of these type of structures, these movements or the pressure variation and all happens in the first few years where consolidation, where it's still getting consolidated and all. So I will recommend as an average, during the construction plus at least 3 monsoons, okay? So, and then maybe you can take that overall 4 to 5 years during construction plus 3 years
Maybe
minimum.
You can say that we have a EPC contract of having a DLP of 5 years. Yeah. So that 5 years is sufficient enough.
Yeah, it must be. By that time, we will get enough warning and enough, the health of the system will be understood by that time. Thank you, sir.
Thank you. Now, before concluding the session, I would like to invite from the audience a few questions if they want to, 1 or 2 only, because time limitation is there.
Afternoon. I'm Amrendra Kumar, sir, CGM looking after Hill Estate. And we are fortunate that we have engaged with all 3 experts that are present here. I have a question with Naveen James. He has mentioned about this landslide susceptibility zone mapping. So is it feasible to map, prepare a map in such a large scale that is actionable? I want that like a Kullu Manali or so, a 30-kilometer stretch. Can this susceptibility map can be mapped that is actionable, landslide can be predicted in advance? And what type of input is required? Can it be done in a shorter period? Some area mechanism to gather that data?
Yeah, so the map we prepared is for the entire state of Himachal Pradesh. And the data that we require are freely available. The main data is the digital elevation model, which we can get from Cartosat, that is ISRO, or also Pulsar, or this SRTM. So they are freely available. We can derive it from that. The resolution varies from 12.5 meter to 30 meter, depending upon the type of DEM. So, and we generally, the susceptibility mapping is like a first level of understanding which are the susceptible zones. So if we can do it for a larger area, that would be best. For a smaller area, we have to to capture the accurate the terrain features or terrain geometry. We probably have to do advanced surveying techniques such as a drone survey or DGPS survey, and then we can do much more kind of stability analysis. We can do it, especially for those high susceptible zone region. So we can do it at a macro scale level, basically for a state, we can do it. And from that, first we identify which are the hotspot zones, and much more rigorous analysis can be done for those locations which are on the high susceptible zones. I think I answered your query. Okay.
Good afternoon. My question is towards ma'am. It's basically one leading to the other. Pakyang Airfield, which was the highest at that time RE wall, which was constructed 75 meters. And I believe it's got some problems. So that leads to my second question to that. We're doing a lot of landslide, I would say, protection work, stabilization work all over the hills. What Director Sir also asked, monitoring and all. So we're finding that 3-4 monsoons it's stable, but thereafter it started failing. There's a lot of money and a lot of efforts go into it. So first of all, Pakyang Airfield, does it give us a lesson? And certain failures which are happening, where it's stable for about say 3 to 4 monsoons, and thereafter it destabilizes.
Sir, I will say that this 3 to 5 years, the monitoring is only where the geotechnical stability is attained, there we can. But basically, if it is a geological or that type of deep problem is there, that will not stop. Whatever we are doing is just we are really trying to see that the infrastructure is protected, but still that problem is there. So the Pakyong you told, as I know the case study very well, there was an overall problem was there, and the UK consultant who was involved, the MOT, their UK team has told that this area there, the airport cannot be done. It cannot be done. So such a deep problem was there. But for our country, we are having limitations. We are having certain political, our strategies are there. So they have gone with the same. But at the same time, where the problem was there, the holistic approach was not there. Like Oja sir has told, the subsurface design and implementation was done from the beginning, the Pakyong problems would not have come. But whereas whatever it is designed properly, it is standing there. There is absolutely no problem. But subsidence and the subsurface drainage problems has happened. The same way for the Uttarakhand, I know that you must be mentioning about the Uttarakhand slides, especially the Uttarakhand packages and all. So there also, if there are the geological, very typical issues are there, which may be the global examples, not just for India. And whatever the protection systems or stabilization systems adopted is not correcting the issues. So that might be repeatedly coming, and definitely that cannot be just solved by 3 years monitoring or anything. Those type of areas, very specific areas, need to be monitored maybe for the design life completely. It cannot be left after that.
I think there are no more questions. So we again thank Professor Ojha, Professor James, and Ms. Minimol for their presentation on the landslides, erosion control, and prediction issues. And we conclude the session. Thank you.
Thanks to the esteemed moderator and the panelists. May I request you all to please join us front and center for a group photo op. So ladies and gentlemen, we are now taking a break for lunch, but before we do that, let me remind you all once again that we are once again congregating back in this hall at sharp 3. We will be starting the post-lunch session at sharp 3. And of course, joining us for the post-lunch session is none other than Shri Anurag Jain, Secretary, Ministry of Road Transport and Highways. He will be joining us for the post-lunch session. So kindly do join us back in time and help us in starting the post-lunch session in time. And meanwhile, once again, a gentle reminder, the nomination panel for 2023 National Highways Excellence Award is now open. However, the deadline is the 15th of February 2024. So don't forget to join us back in time for the post-lunch session, wherein our special addressee is none other than Shri Anurag Jain, Secretary, Ministry of Road Transport and Highways. Thank you and see you after the lunch break. Ladies and gentlemen, the lunch is being served in the back hall. As you exit the hall towards the back, you will see lunch area. So kindly proceed towards the lunch. Thank you.
Nations